Hey, what's up, career family? So today, I'm gonna spend the whole day trying to build this on Android. So I have a rendering pipeline, which right now just supports Bloom and normal. During this day also, and yeah, I'm me, the person talking. I'm gonna turn my video off, but for the purposes of identification confirmation, I thought I would help to confirm my identity so you don't think you're getting scammed in some way. You'll know you're getting scammed. um, so yeah, so this is what I have right now, and it supports like nightlight. The goal, where's my glasses? So we're gonna add stereoscopic 3D. I don't know. This is gonna be a long working day. Oh no. So it's gonna be a long working day. The main goal, if I'm honest, is to get something happening with the Android app. But the other goal is to get the stereoscopic 3D working. And that might be a good thing to knock down earlier as the problems with Android crop up. And I'm doing this with no experience. So I've not written any Kotlin code. I took a tiny peek at Kotlin yesterday, and I have configured a pipeline on Android in C++. And I have these reference projects. You can find on my own repo the one reference project, which you'll probably see opening here. And there's an Android project. For some reason, Google keeps breaking the projects. I don't know why. It must be easier to have them break. But this old Mac project still works fine. And it includes a pipeline. The pipeline is a lot different than this new pipeline. The new pipeline is more about multi-stage. So I'm gonna get rid of my face here because it's just going to be a distraction. But I'm gonna show you this multi-stage pipeline, just so we're starting off with something that kind of works. So I'm just capturing from the device and the simulator, and the simulator will update depending on what we select here. So this is kind of a pre-pass. I call it pre-bloom. So the bloom effect is the blur effect. This one thing we want to add to the pipeline, and I do it like 6 times rather than doing it expensively on some smaller images. So you can see these images are 372 by 566, whereas the real render target is 1488 by 2266. So there's the bloom pass, and then this 3D pass, and then finally a 2D pass that does I don't know why this shows up as the presentation. That's a bit weird. Oh, it's because of what we have selected. So if we go and select the final one, no, I'm still not sure why that shows up, but that isn't that isn't the goal here, is to have this thing reflect what really shows up on the device. The goal is to get an Android app instead, so we can release that GPU workload. And as you can see, the final output is this earth. And literally, like, I'm doing this just straight up, like, I downloaded Android Studio, and yesterday I made this tiny sample project where I did, most of the time was spent in trying to figure out why it was insta crashing. And I think it's because the emulator that I picked was the wrong version. So I made this thing called Hellfish. I'm gonna make another new project, and literally these are the only files in here. So this work is probably gonna get redone, but literally I don't know how to write Kotlin. I don't know what a late init var is. I'm guessing that's like a lazy var. Yeah, it must be. And I use ChatGPT to figure out this try catch block. But anyway, so not going to use that one. I'm going to make a new project. And I think I want to do a no activity project or empty activity. I honestly don't know. This time I'll try empty activity. I'm going to put it, looks like it's going to my desktop. This will be called Droid Render Demo Earth. And I think the default everything is probably good. So I guess I can't build this project yet, but in the meantime, let's go online. And it's funny because I still call it Droid, but I don't think that. And you can see I've clicked this before. This is the same thing I clicked the other day. I figure go to the source, go to the real docs. So in this demo, as I says, don't expect me to be able to quickly do everything. So let's just follow this. So in order to draw graphics with OpenGL ES in your Android application, you must create a view container for them. One of the more straightforward ways to do this is to implement both a GL surface view and GL surface view.renderer. A GL surface view is a container for graphics drawn with OpenGL, and GL surface view.renderer controls what is drawn within that view. For more information about these classes, see the OpenGL ES developer guide. All right, so this one is kind of like the view, and this is more the renderer is like the, well, I won't think of it in terms of MVVM. The renderer is the renderer, so the thing that sends commands to the graphics card. All right, so it looks like this is the first line to copy. Uses GLES, blah, blah, blah. And let's kill this other project. We're gonna be going back to this project during this video. So this is kind of like trying to accomplish 2 apps at once instead of just one, which makes it a little, I guess you could call it efficient or foolish. So here's the manifest. And I don't know where to paste this in. So I would already at this point look at my reference application because I know I had this working before. What is the manifest file called? Android manifest. I'm hoping this project has that file. Yes. I think we need this one to write external storage. I don't know if that's for cloud or for files. If it's for files, we need it. Oh, for example, beginning with Android 4.4, it is no longer necessary for your app to request write external storage. All right, so we no longer need that. All right, so here is the line uses feature Android GLES blah blah blah. So in here, we put it at the same place. So that's probably cool then. Oh, this is Hellfish. We wanted the other one. Or no. Yeah, this one is Hellfish. Get rid of Hellfish. So we've added that one line. Then what does the docs say next? Oh. Well, that menu sucks. I don't know why that thing keeps popping up. If your application uses texture compression, you must also declare which compression formats your app supports. I don't think we need that. For more information about texture compression formats, see the OpenGL Developer Guide. Create an activity for OpenGL graphics. Android application that uses OpenGL have activities just like any other application that has a user interface. The main difference from other applications is what you put in the layout of your activity. While in many applications you might use text view blah blah blah, in OpenGLS you can also add a GL surface view. Alright, so let's do it exactly the way they do it, but maybe renaming the things. So these are .kt files. So new Kotlin class. So this is for the surface view. What do I want to call it? I want to call it graphic surface view. And I get into this habit of renaming things because I just want to dip my toe into editing Kotlin code. So there's graphic surface view. It looks like these things turned red. We need to import the stuff. No, we don't have this. This I think comes from the tutorial. Oh shoot, this wasn't the surface view, this was the activity. So I'm going to call this graphics activity. Can I rename that? How can I rename this? Yeah, I'm going to call it graphics activity. I'm not sure why they're using 2.0 instead of like 4.0, but I'm just gonna roll with it. So now it's about the surface view. Create an open glass 2.0 context. I kind of want to look at the other project again. I don't think I can just open that project, can I? So I put these things into reference projects. Okay, so yeah, there's problems with this project, which Google just decided to add. But this was all done in Java and C++. So let's look at these things and see if they're like similar. So the activity creates the view. And that's kind of what's happening here too, and it does set. We're gonna need this on pause and on resume. So I would look that up like right away. Like I'd go to ChatGPT. And right now, I think I'm running out of my free questions like super fast. How to add on pause and on resume in Kotlin activity on Android. So I'm just going to copy those and plop them in there. I can't tell if it is accepting this or why it made these letters gray. And if I recall, you can't just print. How do I print to console on Android in Kotlin? Example. Yeah, the log class. So we'll just do debug messages. So I'm going to call this graphics activity on pause. I'm just showing you my process, and I don't know Kotlin, but I mean, I know code. How do I get that to autocorrect? MSG. And surprisingly, we're not doing a native app, so it should be a lot simpler than the old one. I think the real trick here is just going to be loading the shader files, linking the shader files. I'm going to minimize this again. Anyway, obviously we can't compile because this guy doesn't exist. We can't import it because that doesn't exist in any framework. So we've got to create it. I think it's in the tutorial. Yeah, my GL surface view. And we're just going to instead name it graphics surface view. New Kotlin file, graphics surface view. And we'll do the copy pasta. Boom. And I'll just paste over that. Bloop. Bloop. Oh, whoops. I'm renaming the wrong things. There we go. And we need the renderer. All right, let's go back to the activity. This bad boy became that bad boy. So now we need my GL renderer. Oh, but I want this one too, the dirty mode. This is necessary if the frames can sometimes take longer. And we'll just set the frame to dirty. Is that where we put that? One other option additional to your GL surface view implementation to set the render mode to only draw when there is a change to your drawing data. Yeah, we want to get used to this dirty mode right away because we need that. All right, then we need the renderer. So we'll call it graphics renderer. And I'm a little bit at a loss. I don't know what this UI theme is or how we're gonna get this graphics activity to just show up. I might have wanted to start a blank project. So these are the sufferings that should enhance the type of activity that we're doing right here. All right, so I'm gonna name it graphics renderer. So we've called it graphics renderer. So the surface view uses the graphics renderer. And I'm just gonna remove these comments. The good news is it's OpenGL2, so the shader code that I have for OpenGL2 is gonna work, but it all needs to be redone. The hardest thing, there's gonna be two very hard steps. The first is gonna be getting our first triangle to show up, and the second one is gonna be the first compositing action. So I've done only a little bit of homework here, and it looks like in Metal is textures. In OpenGL it's frame buffers, but I don't yet know how that works. That's gonna be a hurdle to overcome. We're gonna kinda overcome several hurdles. And in the past, what I did was first to configure the OpenGL app on iOS, but I don't think we need that. So anyway, so I think we don't need any of this crap. This is like auto-generated stuff. Let's delete it. And main activity, because we're gonna use the graphics activity. I'll try to build, I'm pretty sure I can't yet. Yeah, so just for this activity, it's gonna be the graphics activity. Whoops. I don't know if we need the ampersand earth demo. We just put that. I don't think we need a theme. Can we run it? Oh, it looks like it crashes. And I think this is the log. Fatal exception. Unable to start activity, blah, blah, blah. Null pointer exception. So I think I have to do what I did in Hellfish, which was to do that try catch. Let's just see how did I arrive at that before. So I went to ChatGPT, is that I have this error log. And then I'll say, here is my Kotlin code. It looks like they put the dirty after set renderer. What? Really? That's it? Alright, so if we change this clear color, can we make it turn red? Yes. Alright. So there's some semblance of earthly activity going on here. So ChatGPT is great for crap like that. Then maybe, I mean, we need to to cross that barrier of drawing the triangle. So this is gonna get a bit shisty. This is what we need, the attached shaders. What we really need is to load a file. All right, let's go through their process. I don't know, what file this goes in. I don't think it needs to go in a particular file, but I don't know. So I'll make a Kotlin file called shimwiz. And boom goes the dynamite. Then we gotta import all this crap, right? Sure, we'll make the triangle and the square. We just want to be careful. All right, we don't need the square. Let's just do the triangle. Okay, maybe like one file could be called triangle. Let's do it their way first, and then do it our way. What a shit thing. So you cannot just click rename. So there's triangle. Let's make square. And I don't know if these variables are gonna collide with each other, because I just don't know how Kotlin works. Alright, so let's import this stuff. So that does exist in the other file. So it can see those things across files, it looks like. Can you do let in Kotlin? Is there a let in Kotlin? What is the Kotlin equivalent of Swift's let? Oh, I put Jotlin. Val. Okay, so it's val and var. Val. Is that valid Kotlin code? So I should be able to take this code and have this print over here. So it's what, log.d. Can I just put A? Is that cool? So we can see that. Yeah, let's change the tag to this file, graphics activity. I like that tagging right away because you really end up needing that later on. Okay, so can the app run? That's the question. Now, why doesn't it give you the printouts right away? Like, that's wacky. So you have to click on the little cat to get the printout. Here it is, ABD and on pause. Huh, I don't know why on pause got called. Shouldn't it be like on start or something? Oh, no, I logged on pause instead of on resume. How do you clear? Trash can. Yeah. All right, let's run it again. There it is, same red thing, boom. All right. Woof. So we're on renderer. Why can't it see square? What do we call it? Square 2. Unless I made a typo somewhere. Alright, blah, drawing shape. Why did they put dot, dot, dot? Oh. We just need more stuff in this triangle. Yeah, that's a real weird way to do it. To put the shaders on the objects like this. The function is called fun. That is fun. Funny. And I like to keep building to keep seeing if it keeps working. So triangle and knit. Where did these have to go in this function, perhaps? Why can't it see that? I think we could put those into that function, perhaps. And no semicolons. Okay, now it can see that. What is this dot also? Let's look that up. What is also in Kotlin? Applying a given block of code to an object and returning the object itself. You want to perform some actions on an object without modifying its state. And you need to return the original object after the operations. Alright, so that one is politics. I can't tell. It looks like this goes on the triangle. And then on draw frame, we do triangle dot draw. Hey, Shinobi. Well, that that is the fundamental unit of a computer program. Oh, there's our triangle. So the next step, which I don't need this tutorial anymore, that's all I needed it for. Now it's going to be about reorganizing things and converting some stuff from Metal to Kotlin. About example in Kotlin of rendering to one texture, then drawing that texture onto a frame buffer, or the OpenGL ES equivalent of a metal MTL texture. Essentially multi-stage rendering. I think we want to keep this one for later. Oops. I assume comments work the same way as any other language. Yeah. Oh, good. It auto close that comment for me. Now what we need is an example of loading a file in Kotlin in an Android app. Let's look at the old project. So I think there's something about saving files, but it's in Java, not Kotlin. Do. Yeah. Oh. No, I'm still a little confused. Where's the other project? project disappeared. There it is. So where are the shaders stored? Resources. I think we're not actually using that resources. Okay, we're using assets. And yes, the shaders are just simply stored in assets. There was some reason for that. I don't think we need all the extra stuff associated with resources. But how is this assets directory linked up? Oh, the global find is such a bag of suck. Let's zoom out for a minute. Now it seems daunting, I'm gonna be honest. In this very video, before the sun goes down, or even after the sun goes down, on this Sunday, May 26th, Memorial Day holiday, if we can get, how far can we get? And why do I already feel like stopping? This is why I do it on the video, that when my heart tells me to stop, I keep myself online for accountability. Now, I don't know. Yeah, so this is daunting. I mean, to get all these different pieces of it up and running, and even the stereoscopic will be daunting. I don't know why I took that little aside right there, just to kind of realize that it would be daunting. All right, so what is this UI folder? I make a package as a directory. So I don't know if main or if assets is, there's like these three little lines. So I don't think assets is a package, it's something else. But I don't know. They keep changing this. I never understood it. Let's try a package called assets. This seems wrong. And in here, I just want to make a file called junk.txt. This is junk. I think directory is what we wanted, not package. Why don't I have the option? Maybe it's an Android. I mean, it seems like Android resource directory would be the answer. For some reason, I feel like it's somehow not going to be the answer because they're going to want some kind of associated metadata with the files and junk. Let's try to delete this shiznit. Let's just go with what sounds logical, an Android resource directory. I'll make it named shaders. Where is it? Oh, it doesn't make sense to put it in the Kotlin file there, or Kotlin folder. It's more like app level. But I don't know where it was created. So that's a little bit scary. Shaders. Let me go into the actual folder. But I don't see shaders. Oh, there it is, shaders. Okay, I would put it in here in res, but it doesn't show up here. If we can just drag that in there. So these are maybe not necessarily organized assets. Let's delete shaders. Can we do that? And remake it. Let's ask ChatGPT, what is an Android resource directory? Is that a good solution for storing files and reading the files? I do not need any sort of metadata associated to the files. They are just simply files that I want to load. I don't need to save files in this directory. Only read files. Using resources raw is a good solution for storing files. Okay, does raw exist by default? So there's raw. Let's add a new file. Shimsham.txt. And we can say, yo bro, where my shimsham at? You got shimsham? I don't got. Shit, dog. This sucks. Alright. So, provide an example of reading a text file from resources raw and printing the contents of this file as a string. I'm gonna do the same thing I did in Swift, which is to make something called file utils, which I guess is a Kotlin class. Can I make another subdirectory in here? Whatever, I'm not that concerned about having the files be organized. That's like, I don't mind flattening the files. This is, see, they're trying to bully me into putting this text view. Well, I'm gonna make a cup of coffee. Actually, I still have a quarter cup left. So I'm drinking this way too slow. I'm like nursing it down. Yeah, I'm gonna brew up a batch. I'll be right back. All right. So we may be staring at this triangle for a long time. All right. So excuse me. Let's do these codes. And I guess the main init or on create. And we're doing it with file utils. And I want like a static function. How to make a static function in Kotlin. We can do that with the companion object. Let's see the singleton pattern in Kotlin done properly. This may be even the better way to do it, just with object. Okay, that's cool. Why doesn't Swift have that? So this is just like the runtime instance of the class right there. That's funny. Let's do that. Let's learn. So object, boom. Then what, we can just use it like just raw shkabiz. What is this? Why did we pass this? Why does it need the context? What is the context there? I'm a little confused as to what the we can just try putting this. There's our shimsham. That's kind of cool. So it just auto links to that file. Safer that way. Oh look, there's a print ln too. Let's try another one. Print ln Bob. And let's also print Bob Robert. And then let's print Rob Bobbert. Ooh, uh-oh, 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 uh-oh. So it doesn't like shimsham. S is not a valid file-based resource character name. Oh. So I think it just has to be lowercase. That's fine. That isn't a difficulty. That's usually what I do anyway. But now we're gonna have to lowercase this shimsham too. Man, that's harsh, man. That is some strict Hey, got it. Yo, bro, where my shim sham at? You got shim sham? How do I see what type this is? None of the command keys are giving me like a... So content is a string. So I don't want it to read line by line, although that worked. How do I make this return the Swift equivalent of data type object, not read line by line? A byte array, yeah. Then we probably need, this must be why I had that in the other project, the size of the file. How to get the number of bytes in a file in Kotlin. Can the file object, can the file also read the bytes? So I'm gonna make fun get number of bytes from raw. And what I want is an integer. How can I make this work with a resource ID instead of a file path? So I actually want to return 0 if there's an error. What else can asset file descriptor do? Can you do get bytes? So that's just the descriptor. That's what I really want for the number of bytes, is just the descriptor. We should have the other one too for a file path. I don't want to get too hung up on this right away, but we are going to need a file path string. Now, forget this. We don't need this right now. Let's only get what we need to get to our goal. I don't even think we need this one. Is there if let number of bytes equal there's no autocomplete for nothing. Can you do an if let in Kotlin? So we just say let number of bytes equals blue. Blah. What's it not like in here, man? I'm a little confused. All right, we for sure don't want that, the multi-line reader thing. Oh, it's not let, it's var or val. And then what is the syntax? Can we just name it itself? All right, I just want to log this thing or print this. Println AAA arrow. Can we make a string for the number of bytes? All right, kill all this shiznit. Maybe we don't need string. What is wrong with this? Oh yeah, yeah. My number of bytes is not optional. That's the weird thing. So we can just simply do if number of bytes is greater than 0. What is wrong with this syntax? Okay, so we need the parentheses. Whoops. So our number of bytes can just be the true number of bytes. And then finally, we can return this buffer. So how does try catch finally work? Is the finally code always called? The finally block is optional. It contains code that is executed regardless of whether an exception occurred or not. I don't want to use also. Can you modify this to not use also? I don't understand the value that we're getting from also right here. What is IT? I don't know where IT comes from. Yeah, I like this implementation better. It reads a little bit more straightforward. So logically, oh, so we wouldn't get to finally. So I'm thinking we don't want to use finally. In both cases, we have to do this stuff. We have to close the streams. I don't know if we do output stream dot flush, do we need output stream dot flush if we're doing output stream dot close? The close method implicitly flushes. Yeah, that's what would make sense to me. So this variable of length, I don't think is, we can just use buffer.size. And what did we do in the other project? I'm a little bit curious again for loading assets. I think it was simpler. I guess it doesn't matter. Yeah, it doesn't matter. It seems overkill to have this input stream and output stream. But let's just get it working and then go back. What is this? Why would we make a byte array out of number of bytes? Oh, wait a minute. Oh yeah, that's our buffer. That's just the buffer we're creating. I'm gonna name that file buffer. Buffer in a graphics project has other connotations. Now in XCode you can click back. They don't have that here. It doesn't work. In XCode it doesn't work. Now I want to see if there's simpler alternative? Is there a simpler alternative for reading the file content other than byte output stream? Well, let's just have to see if this works. I like that better because it's not using two streams. But I don't know if it works. Then what about converting this byte array to string? How in Kotlin is the simplest way to convert byte array to a string? Alright, let's see if that works. Let's just see if we can run. So it's crashing instantly. Is this the source of the issue somewhere in there? Yes. So is it that line right there? Okay, so this line has a problem. So let's give this one to Jibita. How do I remove the compression? Resource raw, no compress. Well, maybe it's good to have the compression. Why can't I read? Oh. Oh, I see. It's probably compressed. Yeah, we don't need this compression. None of the shader files are going to be big enough to need compression, and the image files are going to be already compressed. So we definitely don't need these assets compressed. Create a new directory named raw no compress. So this is what learning is. Let's see what ChatGPT says about that one. Okay, I think this is what happened in the last project. So there's resources, but then there's the assets directory. So my original instinct was correct. Using asset manager. Yeah, that's what I did before. I don't, will it automatically create that asset directory for me? I'm just a little bit confused. No, it's putting that in resources. So I want an asset. So there's just not an option for like asset directory. If I just make one called assets. I don't understand what happened. How do you make the assets directory in Android Studios? Right-click app source main folder, new directory, name the folder assets. New directory. New directory. I mean, that's what seems. I mean, then I just do this assets. So it doesn't like see that or something. But there it is. There's assets right there. Can I drag it in there? It could be because nothing's in there. So I want shim sham moved. Where into assets? Whoop. Now will it appear? What is sample data? I don't want that. Maybe assets has to go in source, main. So I see res. Okay, that whoop. There it is. All right, there's shim sham. So we don't need any of this shit at all. None of this resources. We just need the asset. All right, let's see if our buddy can do this for us. Can you change this to work with assets directory instead of resources directory? Okay, so now we just switch to a file name. That makes a lot more sense. Can this function use some sort of file descriptor instead of a whole input stream? Yeah, that's what I want. Is just the file descriptor. Is this a real thing? So we're not doing from raw, we're doing from assets. And I have some gut feeling that we can just put shimsham.txt like that. I mean, how much do you want to bet that would crash? Uh-oh, what's it crying about now? All right, we don't need these directories. We don't need raw. All right, it didn't crash. That's that's good. And we just print the content to string. I gotta get used to this let pattern. So contents type. What type is content? Byte array. How can I safely convert content to a string? So this is a string optional. What's the type here? So it must be some kind of like context. So we can use that outside of there. All right, I think I want to flush my logs. So it isn't finding that file. I don't think we need the context anymore. Oh no, it is using context. Let's look at the old project. I think I called these outlets. So I did context, get resources, get assets. I mean, is that the trick? Context.resources.assets. So just context.assets does exist. It is still giving this error. The file is now in assets directory at the same level as the res directory. Let's put the usage for context. Here is my usage. Verify that the assets directory is located directly under the main directory. So maybe it is compressing it still. And there has to be an assets no compress. It is in main. I don't even see the assets directory show up now. Let's just add more logs to make sure we're current. So this is some kind of a keyword that it's looking for automatically, assets. I don't think the no compress was the right idea. Let's read the rest of what Chibata said. Get rid of the old one. All right, just as a dumb idea, is it just the file descriptor that has the bug? So if I get rid of that, and I just say number of bytes is 100, yeah, so that worked. It read the file. The only problem is this function. It cannot derive the asset file descriptor. So maybe that's why they originally did the input stream. Can I use some sort of other file descriptor other than asset file descriptor? Parcel file descriptor. Well, yeah, let's not get hung up on this thing. It's probably not hurtful to spin up that input stream object, especially since we're not accessing the bytes. Let's kill logcat just to make sure we're getting a fresh read. Alright, yeah, so it read up the shim shams. Let's modify it one more time. We can say OpenGL is cool. There it is. Proof. Then finally, I just want read file from assets as string. We also are going to want an image. Let's not do that quite yet. Read file from assets as string. And this returns a string. And we'll do like exactly what we did here. I'm not so sure about the shiz whiz. Or if it's the right type. This is optional string, that is optional string. Like, can we just put string it like that? Or string content? No, I think I'm a little confused. So we for sure could just put that there. Let's see. Can this be modified to not use let? Okay, so it is kind of necessary to use the let. This, I think, is the smart way to do this. I don't see the type of string content. Be like, what type is this type? So can we just have that be the whole function? You need the word return in Kotlin. What does the other, well, yeah, I don't want to get too hung up on loading files, but obviously that's kind of like a unfortunate step that is absolutely necessary. So let's just say file content. Contents. I want to try something weird though, which is to put one valid one and invalid one. So there's contents 1, and then I'm going to make contents 2 be shim, sham, shimmy. Let's cook up this beast again. So it doesn't crash. That exception, I think, is like the exception that happened. Now I'm a little curious in the old app how I got the file length. Okay, I did do it with the input stream. So it would make more sense to use a descriptor. All right. So what we want now is this is kind of a stupid verification step. Well, we want to start organizing these shaders into something. In this new system, there is only indexed drawing. So literally in the shaders, even the Gaussian blur one, those could be renamed to Gaussian blur indexed, but it should eventually be implied that everything is indexed. I don't need anything not indexed. It just creates too many redundant similar shaders. And sometimes just putting 0, 1, 2, 3, 4, 5, 6, blah, blah, blah is fine. Doesn't slow it down. And it keeps the population under control. So in triangle, so it's real nice in Metal that the data can be organized in these simple objects. So I've made this file of primitives, and these directly match each shader type. I really wanted that too in Kotlin. So I want to see if, well, let's see if ChatGPT can do it for us. Can you convert this to use structs with X, Y, and Z instead of one solid array? This is Kotlin. Let's see if this works. Ooh, now this is marked as a data class. That's a bit interesting. Okay, but it looks like this is somehow not flat mapping or whatnot. Now it can't use this for OpenGL. Is there some type of flattening for the float buffer? So I think it's a little less efficient to do it this way, but it's going to be so much easier to read if it works, which it doesn't. I think it's the times 4 should be times 4 times 3 maybe. Why does it put times 4? Now, is there like a shader debugger? Is there a error saying? All right, let's undo all those changes. And I really want to have some understanding of what's happening here. All right, that's about where we stopped. So it should work right here at this point, yeah. Why is this not times 3? It seems like that should be times 3. So I'm actually confused. Why is that times 4? I count 1, 2, 3, 1, 2, 3, 1, 2, 3. Oh, 4 must be like the size of a float. How can I do size of float in Kotlin? I don't like using 4. Float.size in bytes. I think that's what they're doing, the size of float. Yeah, so if this was instead like short, it should crash. Yeah. So I do want to get that organized into a clean snip wisket. Let's try to do that. So we want times 3 times 3. Maybe that was the issue. Nah, not gonna show that. I mean, can we just tell ChatBT this simply doesn't work? No triangle shows up on the screen. Is the array not getting the correct contents somehow? Oh yeah, so maybe it's not times 3 times 3. No, there's 3 of them though. Oh, because we're doing triangle chords dot size. Yeah, so I made that too big. Nope, still don't work. This is where graphics can be a pain. And really the metal one is a lot better. So in metal, we can inspect what's on the card. So when I capture the frame, I can, for example, go here and I can see exactly what's getting loaded into the buffers. This is how it used to be, where you just have to kind of guess what the problem might be. I mean, my feeling is that this weird inlining is somehow wrong. I just want to say, how can I convert this into a flat array of floats? So if we do that, and then instead of using triangle chords here, we just put our flat array. I don't know if we can just put the vertex itself. So we have to put each one. So how can we loop through each element of flat array? So we want to put flat array I. I'm a little confused what happened now. That feels like it should have worked. Buffer overflow. Can we just print the flat array? I mean, if we just make this bigger still, like just multiply by 3 again for no reason. So this is all very different. Man, I can't tell. Let's just do this. We'll loop through and we'll just print ln. array at I equals flat array I. Is that okay? Yes. Alright, so we can kind of see 0, 1, 2, 3, 4, 5, 6, 7, 8. Why is it 0 for the last number? Okay, they all have 0 for the last number. So that's too big. But by how much is it too big? 3x the size? Yeah, why would it be times 3 times 3? That's ridiculous. Alright, so there's our flat array. We can see all the elements in there. And then we don't need that extra times 3. I don't know why the triangle would not show up at all. Nope, nope, still not, nope. Let's look at the example code again. Where the heck is the buffer shizwiz? So in this one, we do put all of the triangle coordinates, not one at a time. So maybe we just put flat array. I mean, ultimately, it needs to be a flat array. Okay, is our size wrong for some reason? Triangle coords.size times 4. Allocate direct. We don't need the extra times 3. But then it doesn't work. Yeah, no, we need that times 3. It could be like a doubles versus floats thing going on, maybe? No, because up here it says float array of. Maybe we just need, what is the type of flat array? What is the type of float array of? I mean, it seems like that would be the only difference, is float array of the flat array. Oh, is float array of a function that we made in this tutorial? How do I jump to the definition? All right, so float array of is like a language thing in Kotlin. But for some reason it can't see it there. So can we just say val? So flat array is already a float array. We don't need to convert that. That is the type. The type is float array. So something is wrong. By simply converting to this type and then back to that type. So like, if I just plop in this again, with like some weird underscores, and we put that, yeah, something else is wrong. I mean, it could be that this math shouldn't happen inside of that like weird byte buffer function. So if we just move this outside of the function like that, maybe it is this other math that, or this other junk that it's not expecting, that's somehow putting it askew. Nah, I'm lost now. We just go right back to the function they had. We just comment this whole bad boy out. You know, I think, oh my God. So we always were doing the right thing. It's this coords per pixel, or per vertex. We don't need that. let's undo a bunch of times. So we shouldn't need that flat array or anything. We can go back to this one. And then just simply get rid of this divided by chords per vertex. Huh. There we go. All right, so that's a good way to handle that. So the next huge issue or huge problem to solve would be putting a texture. So I'm gonna dive into that Earth project now. Now, where did I put it? I didn't put the Earth project in there. I just put it here. So the lucky thing is I'm gonna use this as a test texture. It's just a good test texture with some alpha on it. We'll probably need that and you can't drag like that. That would be just not logical. So I'm just gonna call this one test. And there's lights texture. That's for the night lights. The galaxy texture, which I've already resized to be a good square. And the Earth. So do they do let's ask ChatGPT again. Actually, can I just give it this whole class? Can you modify this to load a texture from assets named test.png and add the UV coordinates to the shader program and bind the texture to OpenGL. So what I would do now, what I'm gonna do is make a backup of the project. So I'm gonna call this hello triangle. Okay, actually I want it, can you modify it to also take indices as 32-bit integers. For example, it should use 0, 1, 2 to draw this triangle. Also adding the texture coordinates as you've done already. Thanks. Now, did they add the indices? I don't remember how it works. In Metal, it's different. Where's the old project? What a nightmare. No, this is harder than curing cancer. So what I see here in the node flavors, I don't see any kind of index as an input. Where does the index get involved here? See, this friggin' thing. He adds indices. So that doesn't work. I think this is what we need, the GL utils, blah, blah, blah. All right, we got to do it in steps. This was too much to try to do all at once. So I'm going to use the bathroom real quick. We've confused Elon. So we got to do this in steps. And I think step 1 is going to be to move the shaders into files. So I'm going to make a new file called shitvertex.glsl. And then shit fragments. So I'm gonna do the shit one, and then I'm gonna do texture test vertex.glsl, and then texture test fragment. So very simply, we want to use these shit files. I don't even, so it's in this triangle. We don't need square. Let's get rid of square. Boom. Let's get rid of anything that uses square. Boom. Square. Boom. Let's not use red. Let's make like a nice, like a deeper blue. Oops, I want it like 0.4. This could be like 0.15. Some kind of a purpley, bluey, magenta. I'm not sure what it would look like. Now these files have a blue thing. This one has a pink thing only and no blue thing. Anyway, so the content of our shader code for our shit vertex shader will be that. Man, they really need a back button. Like, how do I go back to the file I was just in? In XCode, it would be right here. I guess I can use this to navigate around, but this doesn't show the triangle file. And the fragment shader code as such. Oh yeah, so we want to put it in this bad boy. I think I missed a line there. No. Why did it put a quote? Oh shoot, those are like the little pieces of the strings. Yeah, we don't need those. Yeah, I think we better just format it like a real file exactly. Let's not be lazy about this. I don't know why it kicks that so far to the right. Yeah, you would think that it would put that all the way to the left like that. So I should be able to double click on these to copy the name of the file. That's a very hard to copy that name. Let's see, copy, does that copy the name? Yeah, okay, fine. And we want to do it just like we did it here. All right, we gotta start building out our little framework, our little yeah. So let's make something called the shader library. I think we can use object. This will be like a one runner dunner thing. And we're gonna need that context. Now can we have an init on these runner dunners? I don't think it needs to be a runner dunner. I think it can be a class. Let's ask ChatGPT. What's wrong with this? How can I pass context as an argument on the creation of shader library? Maybe you can't do that in Kotlin, I don't know. Oh, I see. So it's up at the top. Now, interestingly, I think we only render once because we're never setting it to dirty. So before things can move around, we're gonna need to worry about this dirty business too. I think we just want a little class called shader too. Or shader program. And the shader program, you know, interestingly, we want to reuse some vertex and fragment shaders. So I don't think we actually want this. No. No, scratch that. We want just this library of shaders. So we want val. We'll just call it shit vertex as an int. Now this is getting, if I'm honest, a little bit stressful. So I want like a how can I pass integer by reference in Kotlin. You cannot pass an integer by reference. Well, let's not worry about the very most efficient way to do this quite yet. So we've got our context. Is that auto stored? It looks like it's auto stored. All right, so we're gonna have shit vertex and shit fragment. And I would need to remind myself of the if let or the syntax. Let's practice typing it to learn. I'm a little confused. So if that blah blah dot let then our shit vertex is now this load shader function maybe we need again. Yeah, we'll just migrate that load shader. I mean, I think we can make an optional string And we can just have a function for fragment and a function for vertex. And then if that falls through, let's return -1. Yeah, let's just make it load shader vertex. And instead of shader code, what we want is a file name, which is not optional. Let's just get rid of the fragment one for now. Oh. So first of all, we want just this string. So that function takes a string as an argument. So we need the shader code in the string. So let's do it just like we did it before. Why do we don't have context, val context. Gotta ask ChatGPT, how do I store context variable? I'll put similar to week in Swift to keep a reference on this class. All right, that's what we want, is a weak reference to our context. So we can just keep daisy chaining these things perhaps. And in here context is it. Is that correct? So here, shader code is it. So we don't need if, we just do blot outlet. And then we can load that file. And assign ship vertex to that. Ship vertex equals load shader vertex. If I just do Command C, okay, it does copy it. We'll make our shader library let's just keep undoing so that this can compile again. Or maybe we deleted A. We don't need that. I don't know what that is. All right, so we see our background change to blue. Call the OpenGL-ES API with no current context. So the shader library needs some, let's see. So in triangle, let's see, we're gonna need the programs too from the shaders, that's right. But the programs might combine, or like maybe one program uses a shader and another program uses the same shader. So the point where triangle is created right there. I can't tell. So if I comment that out, do I get that same error? Oh, we have to initialize that, don't we? me trash the logcat and run it again. So that is the problem. GL2 probably doesn't exist yet. Oh, and we're doing shim sham instead of the file name. So we want that to be our file. Whoop. I don't know any Kotlin. I'm telling you, man. I just am figuring this out. This is crazy. My first impression is not honestly that good. This syntax, this is goofy. The if let in Swift makes a lot more sense than that. And it, well, I have to get more used to it, but the it is a bit confusing if you're gonna nest these things. Like if I just put blah and an arrow, is blah and is now it. Where did that it go? So that is now that, right? Is that how that works? Yeah, that's a little bit clever. So shader library might not need to live on the graphics activity. So when we create GL surface view, we don't need to do anything with the shaders yet. Here's where we're gonna have a big like startup sequencing issue that comes up here, where we're gonna need like unowned references, because we cannot, everything that depends on everything is, there is no initialization order that is gonna make sense. So if I just go boom there and create the shader library after graphic surface view, and I tried this load shader function again. What I usually do when I get confused is like I'll put like these logs A, B, C, D or something and see if anything is happening. Well, let's ask ChatGPT. I get this error. How do I have the... I'll just give them all my code. This is the code. How do I have the OpenGL context there? Attempting to use OpenGL ES without no GL context. Create a GL surface view and set up a GL surface view.renderer. So I'm doing that after I create the surface view. So maybe here the context is. It's confusing because the things are not named context. The thing that is named context isn't the thing that we're talking about here. So I think the outer context, this context ref, this needs to be passed to friggin' everything. Whoops. 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 Oh, when you undo, it doesn't go back to the selection you had. A little confused. So this is the big parent. And this is the little guy. So we're just not passing that here to the graphics renderer, but on surface view, okay, the context goes there like that. But that is like a different context. Do we have something called context here? No. No, renderer doesn't take context as an argument. So that's what we have to change, I believe. So renderer takes context as an argument. And then we can do this weak reference thing, perhaps. Then when the surface is created, this shader library can go swimming with the fishes. Let's take a look at this weird thing. So I don't think we need like laden it. We can just go boom boom and then what do we not have an init here? This is the hard part, is Kotlin. So I don't know if we pass context there yet. It looks like it's not optional. And then renderer is going to take this context too. Can we build you up? Yes. No, we should have probably the same friggin' error, yeah. I was just gonna say, are we gonna have that same error? I hope so. Let's see if GPT knows how to do this. There is still not an OpenGL context. I don't understand where the reference to it exists in code. Ultimately, I just want to be able to compile these shaders before draw calls are made in OpenGL. And we'll give it some context. We'll give it, this is context 2. Let's give it, did we give it shader library already? One way to achieve this is by deferring the initialization of shader library until the onSurf is created. Oh yeah, that's what I wanted to do. Okay, yeah. You know, maybe we don't need these weak references. Let's ask it, what is the purpose of weak reference in Kotlin? Yeah, that is what we want, to prevent it from being garbage collected. Or to, yeah. Oh, it's var, not val. Well, can we just make it optional instead? Whatever. Yeah, I don't see those same errors. Alright, so it should be like shader number 0 or something like that. Let's just print it. So we'll just log shit vertex equals, or log.d, or we print ln. And maybe it's 0, maybe it's 1. Yeah, a 1. I think that's good to start at 1, so we can make the default be 0. And if they're 0, they're null. Yeah, that makes more sense. All right, there's shit vertex and then shit fragment. And we've got these good safety measures. Oh, you know, I want to be smarter here and use the it. What's this little orange underline? Oh, could be private. Yeah. All right, so we got one for vertex. Now we need one for fragment. I mean, it could make sense to pass that in as an argument. Yeah, we have duplicate code. So we should, I like having these, but we should just have a generic load shader. Okay, the type is just an int. And we can just use that type. So for this, we'll just return load shader. For this will be vertex shader. Yeah, this is not duplicating code, so that's a little better. So there's the vertex, and then let's do the fragment. We can copy this name. Yeah, so we got 1 and 2. Now that's a very good indication that these were somehow valid, that there wasn't like a moof in there. So if we just add some garble in here, like one of those should flounder or flop somehow. No. I don't know if the file was saved. Huh. Well, whatever. That's maybe not as good of an indication. To me, that's weird behavior. it would be easier to debug if a bug in the shader program would show up as a thing like that there. All right, now we need the program. And what type is program? Just an int, yes. So we'll call that our ship program. So val ship program. Then we'll make a private func load program. So we're going to take a vertex shader and a fragment shader. We can get rid of the comments. It should be self-evident what's happening there. The real comment is this also. So then our ship program is load program of our ship vertex and our ship fragment. And then we should be able to see the ship program. Ship program equals ship program. So that's like the third object that OpenGL created. So it stored that index 3. Might make more sense if that was like index 1 of a different flavor. Now each step of this makes me very nervous. I'm really confused as to what's going on here. So the shader library, we can just pass this into the triangle perhaps. Can I just do val shader library like that? What's wrong with that? How does that get stored? Like here, context. Yeah, we're confusing the garbage collector. Maybe it's just good to get in this habit, this Kotlin habit. I'm gonna make another little backup, but I'm assuming I'm not gonna need this backup. Just be good to have. Put it right there. This way I can more freely just delete stuff from here. Boom. Deleted. 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 And then we can use this bad boy. For all the bad shkabizwits. So can we just do it dot ship program? Yeah. If we can just use shader library as such, so we don't have to do it, because the it is getting confusing. I think it doesn't understand that this is the unwrapped one. I wish I could see the type, this thing's type. So why is that optional? I thought the whole point of doing .let unwrap that. And ask ChatGPT, how can I do the Swift equivalent of unwrapping shader library? It says it is an optional shader library. Oh, I think because I didn't unwrap right there, that's what happened. Well, this was kind of the fear that we go back to the blank death screen. So in these older graphics libraries, it's really hard to tell what's going wrong. might be good to print the content of the shader programs we're loading as we load them. So there's one. I don't see any obvious problem with these shader programs. Let's look at the output here. Error condition, shared attached shader, program shader. Okay, so a problem happened before the ship program was even made. Name this into program. I mean, obviously that won't fix it. Oh, so I'm doing shader vertex for both. Maybe one has to be the shader fragment. Oh God, wow, it works again. That is hugely lucky because I don't know what else I would have done right there. Well, this is just the sauce. Wow, man. Triangle, kaboom. We don't need this heavy hitter anymore. Let's get rid of that. We don't need any of this. Just regular linking up, boom, 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 boom. What's this complaining about? Yeah. So that's not the feedback we're looking for. So this is actually going to balloon into a very tough problem because we're going to have to get the matrices and stuff linked up too. Now there should be some kind of a class in Kotlin, like a high-speed matrix. We'll have to look up what it might be. And then keep in mind the little discrepancies. All right, so what is the next step? I think getting the texture assigned is the next step. Let's reference our existing project again. So maybe sprite vertex is what we want. But these are taking matrices. We gotta be a little careful here. So we're gonna get rid of the matrices for now, and then maybe try to get the matrix set up pretty quick, because that's gonna be necessary. So none of that stuff. It is kind of smart what they do, where they put the V for vertex. Oh no. Oh, I'm confused, because this is the fragment shader with a V color. Anyway, let's not get hung up on semantics. Let's not have the modulate color either. Let's just have this very simple texture. So there's not any sort of matrices yet. And to be honest, I would like to name them the same way that they are named in this other app. Yeah, so I put the word slot because that seemed to make a lot of sense to me. I just want to get into this habit of naming things slot. Now what's weird is this is not gonna work the same way it works in Metal, because in Metal we can build these little structures. I don't think we can do that in OpenGL 2. So we cannot use the same slot numbers. So it has to be a little bit different. But we can use that naming. Interestingly, texture coords will not be, that name doesn't make sense. That's a Nambo Mambo. They're all gonna be just data packed vertices, or like yeah, flat arrays. I expect to run into some trouble with this endeavor here. Yeah, maybe that doesn't make sense because we're not talking about a slot. We're talking about the real thing. In Metal, we're talking about a slot. A little bit weird. So I'm gonna somehow conclude that I should use exactly what I had before. Let's try, nah. All right, fine. I mean, we have to accept this. We're building a temporary state. This isn't a state that lasts. The benefit we're about to derive, we have to throw out. So let's make these bad boys again. Instead of shit, they're gonna be sprite. Sprite, sprite, sprite. Sprite, sprite, sprite. But sprite, well, forget the nomenclature for now. Forget any clature. This and that. Forget it. Forget about it. So I'm not going to be crazy and print these things because I think they're going to work no matter what I have in the file. So I've got triangle, and I think what I want now is like a shiz whiz. I'm gonna call it shizzard. So what we need is a shizzard for my wizard. And we can do the copy pasta. Whoop. But just be mindful of the shizzard. And that already is existing somewhere. Whoops. So those will be the shizzard chords. Then we'll have like a data class. There's so many little things that can go wrong. I'll just call this a textile with a U and a V. Let's take a look at the programs. Are they using 2 or 3 or? Yeah, vec2. And this is a vec2. So these are all 2D, not 3D. So we got to be real careful with this shizzard. So we might want like a data class vertex 2D. I'm not going to get too hung up on the naming because these are going away. These are a transient state. So there's vertex, and we'll have text. And we might as well do like a the whole sprite. So we'll do like negative 0.5, negative 0.5. Then we'll go to the right 0.5 and negative 0.5. Let's get rid of these comments because they're not correct anymore. Now, why doesn't it like these? It might be a compiler issue that it just doesn't see that stuff yet. Then we go back to the left, negative 0.5, and to the bottom 0.5. Oh, these put the word double instead of float. Is that happening on triangle? I don't know why it put that. That's a weird one. What is happening? What file am I on? All right. What doesn't it like about that? All right, let's add Shizzard. I couldn't believe it can't decipher that these are floats. Oh, I guess they get the little F at the end. Oh, I see. So some of them have little F and some don't. All right, then we need more triangles. So we're gonna do 2 triangles. So the next triangle will start at the top right, then go to the bottom left, and then go to the bottom right. So that'll be the vertices, and then we'll do the Shizzard textices. So the texture coordinates will go 0, 0. And this is where having a lot of experience with this makes me a little bit faster than maybe I would be if I hadn't been doing this for a long time. All right. So we'll have those 3 matching those 3, and then we'll see these guys getting involved as they do as such. And they're gonna need a little F. So we want to map the schizzard vertices, not the triangle chords. And we now have 6, not 3. So we're getting dangerous. This is not really vertex, this is more position buffer. And we'll call this one the texture buffer. I'm gonna name them like crap because it don't matter. They're all getting deleted. Then we plug in the U's and V's. This doesn't use schizzard, it uses the other, oh, the schizzard textices. We are using the textices. Now all these dumb things should be constants. And we're not going to even have a color handle for this one. This is going to get hairy. I'm telling you, man, this green triangle is like the last Bowser in Mario. Very hard to get past the first time. Okay, so the colors was a uniform. That is good, because now we've gotten over that hump of seeing that happen. All right, so let's look at the positions. So the it's essentially 0 and 1, which makes sense. So these guys go with 0, these guys go at 1. So we're just gonna plug them both in there. Where is vertex stride? Alright, we don't want these as variables. This is all confusinger than shit. Alright, so we're gonna, we want to position handle and texture handle. Texto. So the vertex stride is essentially 2 in this case. And the name must match the name. These are our 2 names. It's a bit hard. To get it all linked up. So then will be positions. So this, I'm a little confounded here. So after we get this location of positions, let's just not name that it or whatever. We'll have the position handle, and then the other one, the text toe, with text to the bad boy here. And we're not using ship program, we're now using sprite program. Yeah, this gets hairy. So there's our positions, and then we plug in our text, and the text is gonna have the same size, but it isn't position buffer. This is our texture buffer. Stride is the same. What's our vertex count? I think it's 6. And we're gonna want to disable both of them. Position and bad boy. And we want to enable both of those bad boys too. Now, if we were OCD, we might want to stack this up a little bit differently. But as I says, it's temporary. It's temporary. It's temporary. Yeah, forget it. All right. Then we jump into the bad boy here. We gotta look at the bad boy here. And we want to get one of these mofos involved, a shizzard. So there's our shizzard. Whoop, shizzard, boom. We got our shizzard in there. And then we want to fire up our shizzard using our Shadar library. And then, shit man, something's gonna go wrong. The odds of that working are like 0%. I think the issue is gonna be that we're not binding the texture. But I wonder if it can just run. These errors are a little bit confusing. errors, I don't know if we just don't have Shizzard involved, if those errors are there, or if those are new errors or old errors, or when they came about. So we have this one unable to match swap behavior error. I think we can just re-dirty up the frame every time we draw. Let me paste that to ChatGPT and ask how can we dirty the frame? How can we make the frame dirty at the end of draw? Oh no, ChatGPT is rejecting us now. Let's go to Bard or Gemini. Yeah, let's just search in this project for dirty. I'm a little confused. Would it be a word other than dirty that makes the frame dirty or not dirty? Request render, is that the one? Yeah. So in this, okay, so in commit render, I'm doing request render. What is MopenGL? That's so to do that, I think we need a reference to the surface view. Is this where we do it? Request render, yes. So we need our reference to that. Do we not have a surface view? we just need a reference to that. We'll just call it surface view. And we can follow this pattern. Surface view ref, surface view ref, surface view, surface view, surface view. So we can request the render. Will that fix our error? I don't know. Let's ask if ChatGPT is back online again. Uh-oh. Let's make a new conversation. Yeah, let's let that cool off for a minute. What is the issue with unable to match the desired swap behavior? Okay, we can ignore the warning, I think. Now I'm a little curious, is that caused by the triangle? So if we kill that, do we have that? Yes. All right, fine. Let's add the triangles back. And we'll get Shizzard involved again. So I put the code already from ChatGPT, so we don't need it to hit their model twice or bog down their model with lazy requests. The texture, they're not loading a file, or we just didn't copy that part. Maybe we can look at our own old program. It looks like Bard isn't giving us any code right now. I think this is an outlet. Yeah, we need a model to help. Or example in Kotlin of loading OpenGL texture from file. This is the one we want, as a bitmap. Oh, but he's posted code that don't work. Let's see if part of his code works. So we want to read a file as a bitmap. Read file from assets as bitmap. Not quite exactly like that. Are we using bitmap factory in here? We're using a stream. I think that's all we need is decode byte array. It'd be nice to read the variable names right there. So I think it's it0 it.size. that enough? No, this function exists. Oh, now the error went away. So we'll load our bitmap. And maybe need to import bitmap. Or this is a var or a val. Dang, we need that context again. So we can just pass in the bitmap. This is too much context bobbling for what we need. It's a little overboard. Any issue there? And we can use the same pattern again, and it automatically takes the argument and puts it in there somehow. Any issue there? Now we just pass in the bitmap. And the name of a file, which can be this, maybe, let's look at this file. I think in OpenGL, we need everything to be powers of 2. So I'm just gonna make that a little bigger. Test.png. See if we loaded something. Doesn't like that. It's, I think context is not unwrapped. Alright, that could work. Now this is the real learning of Kotlin. Oh, I think it's question mark like that. Was the no, that's whack. So we still got our triangle. Oh boy. So we get errors on the daily, on the moment. Let's just put a breakpoint there. So I'm a little confused. So if I just print hello, will that show up in the log? Maybe I have to stop it fast. Now it's gonna keep puking out the errors. I don't know what those errors are. Maybe because of the Shizard draw. Okay, it looks like it loaded the bitmap. I see 128 and 128. Those are real numbers. So what we want now is like texture integer GL gen resources. Let's see if our chat GPT is back. I mean, I'm almost ready to subscribe. As you know, I've already paid money for AI projects due to my belief in the philosophy. Not because I thought it could be used, but because I hoped for that. Alright, let's see the voodoo of okay, I think we need GL gen textures and text image 2D. Oh man, that is harsh. Whoops. Yeah, this old project is getting to the end of its lifespan. That's what we need. These things, mag filter and all that. Now you can ask me, how far are we away from having Shizzard show up something on the screen? I don't know. It could be like within the next 10 minutes, or it could be like 2 or 3 hours away, depending on how many issues we run into. So I'm gonna make a private var texture slot. Just say equals 0 maybe. Do we have an init? These are the hardest parts right here. So the GL gen textures, how can I in Kotlin use GL gen textures with a bitmap object? I need the array of pixels, don't I? You'll indeed need that array of pixels. This is the one, the create texture from bitmap. I remember doing this before. They're not in the right order on Android. I have a hankering to look at this other project again and see where get pixels is used. Whoops. So bitmap has that get pixels function. Oh, they're using it here, bitmap get pixels. Whatever, I'd take this exact function. But as we see, these exact functions are often problematic. Isn't there a different version of GL text image 2D? So we could say texture slot equal blah. Okay, and you need the question mark here. Let's just see if something happened. Texture slot equal something. Yeah, texture slot equal 1. So something happened. So what is the texture? This is like a fragment. It's not, is it an attribute? Let's look at what these look like. A sampler 2D. So I just want to ask ChatGPT, make a Kotlin function that binds a texture in OpenGL2 using this shader as example. Why did it make it a uniform? Is that what it was, a uniform? It is a uniform, yes. Okay, I believe you. So back to the shizzard. But what is the slot of texture? I think it is 0 in this case, right? Shouldn't it figure out the slot by itself? So what I'm half expecting to get into a situation where the thing is just dumping out red text. Why did we bind the texture and the uniform? Well, whatever. Let's just, so nothing should happen now. Good. And then once we fix it here, or once we add that drawback, we should get back to having the wall of red text. Or maybe it works. Yeah, there's when I was talking about the wall of red text, this is what experience teaches you. So these are the early days of computing, except that text doesn't even exist. There's just nothing. Just a guy in a room. Let's see if these messages can be deciphered. Index is greater than maximum vertex attributes. So somewhere does ChatGPT know this one too? What might be the cause of this? This is too lazy. So I think something is named wrong. Can we put a breakpoint and have it stop the code at that breakpoint? Can this print? So what is just railing out errors? Yeah. How can I make Android Studio pause the program at a breakpoint? Is the breakpoint the red circle? Simply uninstall the app and try again. Yeah, maybe where is it? Oh dude, I can't read any of this stuff. Where is it? I can't read any of this stuff. there like more screens? Maybe restarting Android Studio is the answer. Looks like it didn't close down. All right, now it did. What about like a clean all project or like so is it just railing out the errors? It's just puking out the errors. So I'm not that concerned about the breakpoint situation. What if I switch the simulator to a different one? Oh. Okay. Well, it booted up fast. It used to take a very long time. So it doesn't stop at that breakpoint. Is it just railing out the errors? It's just puking out errors. Is it? Oh no. Can I like debug, like step over or something? If I get rid of that breakpoint, is it puking out errors? Oh, I'm using shit program and I want to use sprite program, not shit program. Now I honestly don't know. I'm not getting that log. Can this print? No, I want to go back to the wall of errors. I don't understand how you say select this device. Does this stop the device? Yeah, I want to stop that one. All right, there's the wall of errors. That's good. It's the same errors, max vertex attributes. What is this coords per vertex? Why is it doing that? I don't think that's the issue. But these should be 2 in this case. But it wouldn't make sense if that was the issue. It's printing a very different issue. It looks like it's like overflowing or something. maybe just printing these handles is an answer. Println. It's cases like this where I really wish I had that tag with the log too, because the tag is sometimes helpful. Of which I'm being a little bit sarcastic. Because in this particular instance, the tag would not make any difference. All right, so there we go. Those are shooting up -1. That seems wrong. Here's a question. Does Sprite program exist? Let's just print it here. No matter what, we've got to get through that wall of text. Let's just print it 1,000 times a second. So it looks like that program exists. Get attribute location, Sprite program, positions. What is this other weird variable? That's like the unwrapped one. Now, right now, I wish there was that also. Now, I don't see, these things do exist, positions and texture coords. What did they look like in the other Shangalang? Attribute vec4 blah. Here we got attribute vec2 blah. Do we have like two things with the same name? We do. Oh no. No. That's the vertex. The vertex. See, in like the old one, old program, do we have like the word positions in quotes? So we get attribute location from the program as such. Seems similar to what we're doing here. We're using Sprite program. The only thing that makes sense is if there's a bug in the program. What are all the things it's printing again? So this should be easy to solve, frankly. it's simply not linking up those strings to those programs. Let's see if it can get this uniform location. And we'll print that guy. I think they're all -1. Yeah. So here's a question. If I went back to the other program, the ship program, and used this text, I think there's just a bug in the program, in the shader program, maybe. Because obviously that's working. So if I used v positions from the ship program, that should come up as something other than -1. Oh wow, I'm seeing something. So there's the square. Interesting. So I don't even really need to look. I'm sure that's going to say either 0 or 1. Yes, it says 0. So somewhere in between ship program. Oh, look at this. Sprite program is using ship vertex, not sprite vertex. See, it's always the dumbest thing. But you just can't tell what might be going wrong. I have a weird feeling that it's just going to work this time. But I might be wrong. No, see, my weird feeling is completely accurate. That is dope, fresh to death, brother. I'm telling you, that's a sprite rendering on a mobile device screen with billions of users. Billions. Let's make a repository. Let me quickly make a little repository for this. We'll call this the Android Pipeline Playground. This is some heavy hitting shiz whiz for the Android. Let me tell you, brother, what is up. All right, now we got this thing. And I'm gonna go ahead and make I'll show you my process. I make a folder called like junk. And then I just will cd into junk and clone that empty repository. And then I'm gonna move this empty repository out of there. And I'm actually gonna close all the programs and stuff down, terminate and exit. And then right into that folder, I'm gonna move all these files like so. I'm gonna cd into that. I'm gonna comment harshly or heavily sprite render and push. So I'm actually gonna delete the old project folder and see if I can link up Android Studios to this folder. It should yeah, it should lose this completely. And we have to open this project in a new window. I know it would prompt twice. Let's kill the old one. Well, that's a good chunk of the battle. So I'm declaring a 5-minute celebration at this point. So, a lot of questions to be asked here, like thoughts of what the next move is. We've got Kotlin Android code running to complement our iOS Swift code. So let's just circle back to this, where we got the little bloom halo we can turn on and off, and the stereoscopic button that just doesn't work. It's too much. I mean, frankly, this is kind of a one-day thing. And since I'm talking right now, I don't expect to get it all done, because I'm going to have to account for this talking time too. So let's nip that in the bud. This chit chat. So I think the next steps are to begin to build a little graphics library instead of having the code all over the place. As we have shader library, let's make something called graphics library. Graphics library. I don't want it to ask me about that crap. I do the repository myself. All right, so graphics library. And graphics library is gonna want like references to everything. Like all the stuff. For sure the shader library. I don't know why that turned red. Oh. Oh. We're gonna all the way up to graphics activity. So we're gonna want to reference to graphics activity from the renderer and the surface view. I have a feeling that we want all that stuff. Maybe not. Maybe let's think about the architecture for a minute. Let's think about all the crap we want. So somewhere we want something called a graphics engine. I'm just going to kind of write down what these things' jobs are. So graphics engine. And the main job here is manage pipeline state at a high level. For example, stamp the bloom texture. Stamp the stereoscopic textures. And call the main draw functions. So therefore, well, let's jump back and forth. So the graphics library, the job of this is reusable code, wrapping paper for OpenGL, and all depends on already having the OpenGL context. So for example, from Shizzard, we want to move that big sprite function, or the texture generating function there, create texture from bitmap. It's funny because I think there's, well, hold on. So there's GL gen texture that obviously generates it, and potentially with bitmaps and all that. There's generate and then bind. I don't know if we need active texture. So clearly we don't. So this is just which one, texture 0, 1, 2, blah, blah, blah. That makes more sense in the OpenGL 1 world than in OpenGL 2. I think this is a rudiment or a zombie that can be killed easily. So this is something we want on graphics library, and we want it to be called generate texture. And honestly, I think it should be an optional bitmap. Let's just make lives easier for ourselves for now. And if we cannot get into there, then we'll just return -1. You know, I kind of also want to, well, we'll put that thought on hold for a second. I don't think we need this stuff. We want this at another stage in the pipeline. It probably might not work without that. Okay, it does work fine without that. But that is not necessary for generating the texture. So buffer.position 0. I want to see if this can be more efficient. Can this be sped up at all to reduce the number of clock cycles to the minimum? that's like the same thing. Oh, you know, I don't know if this did anything or not. So, like, gee whiz. Let's look up, is there a good matrix library in Kotlin that works with OpenGL? Well, let's table it for right now. So the next things to solve is going to be kind of linking up this skeleton and then getting indexed drawing to work. And then maybe we don't want strings, like and as much as possible all these things should be kind of like defined as like variables and stuff. So there's some reorganizing that is going to make life easier in the longer run. So I'm trying to make analogies to this metal engine. So there's both pipeline and engine, but I don't think pipeline really is this separate entity or needs to be this separate entity, because in here we have shader library, and the shader library is kind of what this pipeline is. So we could call that graphics pipeline. Yeah, I think that's a fine name to call it. So rather than shader library, I'm going to call it graphics pipeline. Can we use the refactor? So some of this is going to be kind of lame, just futzing things around. But if we don't do it, at some point, it's going to be a lot more work later. So somewhere Shizzard needs a reference. These are all just temporary things again, but like same as we have to bitmap, it's going to be a reference to graphics. And really, we want something more like the Earth app. We'll just make something here called Earth application. Maybe application is the wrong word. Scene. Sometimes scene is a good word. Yeah. And we got to be a little careful about the order that things are getting created. And we'll just name it graphics. As the graphics library. Graphics as a graphics library. Now we need the ref. Graphics ref. Graphics. Graphics library. Graphics ref. And so the graphics library, let's just make it take these things as arguments and see what kind of linkage issues we get. So we're going to want an activity. I'm going to put all the junk. Renderer. Pipeline. I don't think we need the surface view, but maybe we should put it anyway. And the other purpose this will serve is just holding references to all these things. And we want to follow this weak pattern thing a bunch of times, it looks like. And it'll all be coded up good and safe. So activity, ref, activity, graphics activity. Renderer. As a renderer. And it's good to keep them weak because that will reduce conflicts. Finally, the surface view. this one is the ref. So I think that on renderer we can create this using late init. So the surface view, it's funny because we're passing context to surface view, and I think that it wants an activity, like we could just call it activity. But then graphics renderer 2 will take that activity as well. So we're gonna get a little bit redundant. So in graphics library, we have these 4 things. And maybe one of them's gotta go. But we might need to unwrap them all. So we're not, oh no, we have the pipeline here, graphics pipeline. So I'm thinking all the stuff could be optional. Like like including in the library, which seems a little bit ridiculous. We're going to be unwrapping it everywhere anyway. So we're not passing in an engine anywhere yet. So graphics renderer takes a surface view as an argument. All right, it runs again. So the real question is, instead of this, what will go wrong when we do, instead of this, graphics.generate texture? Seems a little bit like overkill. And we don't unwrap there. So it looks like maybe these things were necessary. I don't think we want wrap, I think we want clamp. Oh yeah, we are using clamp. This is for the wrap property clamp. Cool. So these lines are necessary for now. So how do we use this before clamp the edge? Well, gonna have to reopen that project. So the function was called texture set clamp. Oops, where'd it go? No, where'd it go? Where'd it go? There it is. Yeah, I like it this way because I don't ever think that I use one mode for S and one for T. They can both be combined. So we'll just slowly build out these things too. But the important thing is that we're simply learning. So in Kotlin, it's fun. Texture set wrap. So that'll be both of these. So instead of clamp to edge, it'll be repeat. That'll be wrap and then clamp. And what are we doing with like the min filter, mag filter? Yeah, we want both of these too. So we're using them right here, right? Yeah, we're using linear. And we can name it just that same way. Is that what we did? We used the same for min and mag, yeah. It's good to have that option to go deeper with it if needed to, but yeah. So these ones will be mip map. What one did we use before? Linear mip map linear. And the other one is just linear, right? Yep. Then when we initialize our graphics library, we can just do these things. Texture set filter linear and texture set clamp. Then when we load our texture, this shouldn't be necessary. Let's see if that fixed it. No. I think we have to bind to the texture first. It's a good thing we had ChatGPT, because it could have been very easy to forget to do these linear and clamp and all this stuff. But anyway, fine. Now we've got those little helper functions. We can remove their comments. Then finally, there's another thing on Shizard. Which is just binding the texture. Oops, we're staying in the same program. And I don't think it should be called generate texture. I think it should be called texture generate. And then one more called texture bind. Texture bind. And this takes a texture. And what we can do is say, like, if texture is not equal to -1, bind it. And to be completely honest, we don't really need this on so many lines. Could be broken up into one more function. But I don't think we need to get too nutty about this. Mostly just what we need. So let's make sure this function works. Texture bind. In our Shizard. So we can do texture generate. And in our graphics now, we don't need to unwrap that thing, so we can just pass the potentially null bitmap. Okay, then just to simply use our graphics. No, it doesn't see that. Oh, it's underscore GFX. Texture bind, our texture slot. Can't we do like graphics question mark dot texture bind? Wouldn't that be easier? Yeah, that's fine. So just to confirm, without that line, it shouldn't show the thing. Oh, it does. So the reason for that is because we bound it when we loaded it. Yeah, I'm not too concerned about that. Engineer has to know how to pick his battles. That I'm not too concerned about. So next, we really want to get an indexed draw, and we can start to build a real shader. Really, these are still test ones. Well, we can, yeah, we'll make more test ones because we'll make new files for the new ones. So yeah, just a file, test, indexed, sprite, vertex.glsl. And test indexed sprite fragment .glisl. I think in OpenGL is different though. We don't need a different shader for indexed and not indexed. I'm a little confused if I'm honest. In Metal, they're different shaders. So it is different because well, these are varying. Here, let's look. So there's regular shape 3D, and then this is shape node. But these are positions and colors. They're not like a wad of data, packed data. I guess we don't have that in OpenGL. It's different. Where's like shape 3D indexed? I guess we don't have indexed. So somewhere all over the place in this project should be something called like indices. So there's this function draw triangles indexed. This is using GL draw elements. All right, it's time for a new thing. So as we have Shazard, let's make a new one called like Crumpster. This will actually be quite a lot different. Yeah, I'm feeling very confused right now. So there's Crumpster. And really, I want to do packed vertices like this. We'll call this vertex sprite 2D. And these are going to be Crumpster vertices. I know you can do it. I think I didn't do it before for some reason. Well, how can you do, I think I remember. It's like you need the offset and all that junk. How can you do packed vertices in OpenGL? I don't think I even need to search this up. I think it's the stride. Oh, see, it's remembering. Oh, look at this. That is like convenient syntax right there. Wow. So they're doing a stride, but not an index. I'm a little confused. Well, okay, well, one step at a time. So the Crumpster vertices is essentially going to be these things combined. So literally just moving the same things into here. To be completely honest, I'm already impressed with this Memorial Day workload that I've even gotten a sprite to render on Android. I think that's probably 4 days worth of work if I were measuring in that way. All right, so this Crumpster, so I think we can use the same shaders. I'm not super duper sure. Nah, this is something different. Like it's two buffers, like two of them. No, I'm super confused. This is, as I said, this is harder than cancer. This is like the last great human struggle. So everything is now going in the Crumpster. And there is no more Shazard. What is this 6? Yeah, it's 6 of those, 6 of those. Let's look very closely. All right, so they are doing different attributes. So it's not. Oh wait, so it says assuming buffer is your packed buffer. So I think these are packed. So like, oh man. No, so it's using three handles as such. Nothing confusing here. So it's just packing everything into that array. Here's the kind of crappy thing is that this needs to happen all these different times. All right, I'm moving that to my other screen. Yeah, so it is multiple handles. So we'd need a few things. Like we gotta be able to overwrite stuff in these buffers. How do we do that? Well, only one thing at a time. So let's first create a crumpster and command it to draw. It's on renderer. So there's our crumpster. Then we initialize with these same arguments. Let's make a different bitmap for crumpster and give it some other little different positions and stuff so we can see something change. We'll just make bitmap 2. Bitmap 2. And we've got the bitmaps ready to go. That's the hard part, is just locating the files. Nah, I don't know which file I'm on. Renderer, yeah. Alright, so we're gonna load that huge galaxy image. And we'll feed it bitmap 2. Or let's feed the other one bitmap 2, and we'll feed crumpster bitmap. So we should maybe even see bitmap 2 showing up. Which we don't. And that could be because we're not binding the texture, yeah. So that should help us to confirm this other thing. Yeah, there it is. So you can kind of see the galaxy texture. So what happened there is we've confirmed this bind. So before we just had bound. Well, forget it. I mean, it's I'm gonna say it's obvious. It's a little bit obtuse what's happening. But if you zoom out, you should understand some of the meaning behind it. Alright, so crumpster is the mofo right here. So let's just shift everything like by 0.1 sort of thing, like maybe. Oh, can we combine floats and doubles and stuff? So we'll be shifted that away. And then the Y will be shifted down. And then we should be able to get it to start spitting out errors. So it's not spitting out errors. All right, so literally is drawing twice now. It's using the other vertices. If there's protocols in Kotlin, is there protocols in Kotlin? Interfaces. Let's try building a protocol in Kotlin. So we'll make a new Kotlin file. And I want to call this like bufferable. But I'd like to get this working first because there's a lot of repeating work going on here with these like crazy buffers. This is something that graphics can handle along with that bufferable. I'm overwhelmed right now. I'm out of my comfort zone. So a bufferable object needs to be able to do this type of thing. I first like to create a duplicate of Shazard, just a straight up duplicate for Crumpster, and get this bufferable working. And these will just be all Crumpster stuff. we'll just call it crumps and crumps. And then we'll do our minus 0.1f. And our plus 0.2f maybe. Because I'm imagining there's going to be some difficulties that arise from doing this. Just because we don't know Kotlin. Ew, now these aren't drawing. There's no new thing here. We're using Shazard still. We want this guy. Crumps. All right, there's that. Then there might be able to move it even more, like a little more shiftage, a little more downshiftage. That might be off screen. Oh no, that won't be. Well, whatever. So, what I want is to do this thing automatically. The byte buffer to float buffer. I have a hard time understanding where the context of this put. Okay, so that lives on float buffer. All right, sometimes it's helpful to make the function signature and this is something I consider a graphics job, even though it's more like data stuff. Let's just see if ChatGPT can do it for us. So I have this function and I want to simplify it to match approximately this interface using a Kotlin interface. So the interface that I want is with bufferable. So something like that, and then in graphics, it uses an array of these to So like, I think ChatGPT can kind of, this would be approximately the function, the Kotlin function. Yeah, that's very close to what I'm trying to do. So I think they've fixed my syntax. Thank you, Kotlin. Or I mean, thank you, nameless. Alright, so the Crumpster thing. We'll call this the Crump Vertex Sprite 2D. And then we want the Crump text 2D thing, which writes U and V. Whoop. Yeah, I think they skipped a little bit of it. So like on Shazard, we have these vars defined, or vals. They should be vars in our case. We're getting closer to a real thing that we're gonna keep. So we'd like to, oh no, we're passing those in. But here they're var. So I'm gonna ask ChatGPT again. How can I make variables for X and Y which are initially assigned based on the input constructor parameters? Okay, I just put var in front of them instead of val. And those are like stored in there automatically. Oh, so this is just U and V, UV. But I want var, not val. So these are all going to change to the crumps types. And I think it should still work fine. Oh, we just need to fix this functions. Yeah, so it still works fine. And if we get from the chat GPT, this function, I think I want it to be a little bit different than that because we don't need to loop through and do that. Although it could be, because these could be different bufferable types, I guess. I don't know if there's a way to constrain it. Let's see. Can we constrain this so that each bufferable is the same type and doesn't need to do the initial loop? Yeah. That's what we want. So they're all a T. Yeah, I mean, this technology is amazing. I mean, that's crazy good. You know, I can't read that. I'm gonna reorganize it a little bit. Now, why doesn't it use the put like they did? I think it doesn't know about that kind of code yet. This gets tricky. I mean, let's see if this works, and then we'll fix it. It's like, at the end of all these steps, it's not even going to be different. It's just going to look the same. So the whole goal here with the Crumpster thing is to be able to not have these functions at all. And to just simplify this. So maybe we can just say val position buffer equals graphics dot generate float buffer from the there like a otherwise empty array or something? How can I make this so when graphics is null, it puts an empty array shorthand in Kotlin? The Elvis operator. Oh, so there's like a question mark colon. Yeah, that's what I want. Oh, they renamed it for me. It's a texture buffer. Okay, so it looks like that still worked. The only concern I still have is that the Google provided code was a little different with this put. It seems like the put is the preferred way to do this. Put. So let's try to refactor it like that. So how does this write to buffer work? You know, that might not be a big deal. I have a feeling that we can't do it like this here. The only thing is I want them at a very specific slot. I don't understand how this is working. I think there's a little bit of luck because so I just say like var AAA equals this. Is this, which type is this? We do AAA.put. Yeah, I think that I wanted it to be a little bit different. That could be fine. So if we so I want the same thing, but I also want a write float buffer. So I want this to be float buffer generate. And not gloat, float buffer generate and then float buffer right to the buffer, the existing buffer. Let's just see if ChatGPT can do it. Can you make it so the float, so there is a function that can overwrite repeatedly the float buffer with bufferables? All right, so that looks like that's how the buffers work. They kind of reset and go back to their spot like that. So I would like generate to use right. And this can be named result. Whoa, what just happened there? I'm a little confused. Yeah, we'll ask ChatGPT. I tried to make generate right to the float buffer, but it looks like a type mismatch. Here is the error. Because the parameters inside float buffer right function is incorrect. Expects an array of bufferable followed by float buffer, but you provided float buffer. Oh. Oh yeah. Yeah, that one I should have got. So then these are called float buffer generate, not generate float buffer. All right, now I want to be moving like I want to kind of wiggle one of these vertices. Private var svn equals 0. I wish they had this in Swift, 0.0f for float. That's great to tell between float and double with an f. That's much better than in Swift where you have to write the whole word float to make float. All right, so on every draw, we just want to loop this svn. How can I get float pi in Kotlin? Then how can I do a sine function on a float in Kotlin? Lazy. So if svn is greater than 2.0 times pi, then svn minus equals 2.0 times pi. Then we want to keep overwriting the x value to be like negative 0.6 plus sine value times 0.1, something like that. Oh, these can be like 0.6f. I have to keep remembering that now. Then graphics, float buffer right. We can move these out of here. Oh yeah, see, it's a little bit weird because really in init we wanted to have these position buffer and float buffer, or overwriting the same buffer. I think we did vertices then the buffer. Alright, so that obviously works. On every frame it's updating that little vertice. I have some other questions, but I think that the indexes is the next step. And it might not even be a big step. It might just be this function, draw triangles index, GL draw element. So I think yeah, let's ask ChatGPT. So I have this old C++ code. I want the same thing in Kotlin, but that type should be a 32-bit unsigned integer. Then I need an array of uint32, which is 0, 1, 2, 2, 3, 1. Let's put this on Crumpster. Unsigned integer is experimental. Yeah, we gotta be pretty careful here. I don't think we want experimental. Dang, man, why can't we read these types? I can't. So, dear Sam Altman, it needs to be L2. It could be regular integers. It's hard to see the function signature. No, it can obviously not be a short. No, it's because I put short. So that's 6 or what? So it must be unsigned int 32, even though we don't specify 32. So we need a buffer. Is buffer what we used before? I thought we just used the indices directly. We did. Just an array of indices. I think buffer is the right answer. We'd actually need an index buffer. Let's ask ChatGPT. We'll say, this doesn't work. I think it needs a buffer type. How can I make a buffer of the GL unsigned int type? So it sounds ridiculous, but I want these to be the same way in graphics as we have a float buffer, but these I will refer to as an index buffer. But there's no need for any tricky business here. Just going to be index buffer generate with an array of integers. As an int buffer. And then we want int buffer right. Or index buffer right. Index buffer right. Not float buffer, but int buffer. position to 0. How did write to buffer work? How can I write this whole buffer efficiently in Kotlin? Just buffer.put array. That doesn't exist. Can you instead make it loop through the array and put each element individually? This is result. And we can just use our write function. Val index buffer int buffer. Index buffers, graphics, dot index buffer generate indices with the coalescing Elvis operator and buffer dot allocate 0. So if we put in that index buffer, whoop. I don't know if we can just type it up like this. Alright, so these need both. Can you make versions of these that instead use int buffer instead, or I'm sorry, is it int array? What type is this? Int array. That use int array instead of array int. So it's very similar. All right, so something happened. I can see the only one triangle is rendering. Now that's a tricky one to puzzle through. So if I just nix out that and plop in, oops, I'm sorry, not that, but the GL draw arrays. It goes back to what it was. If I comment them both out, it should draw nothing. So this is really doing something with those indices for sure. It's gonna probably crash if I do more than 6. Couldn't be 12 is the answer. Couldn't be 10. I don't know. It should be 6. There's 6 triangles. It might just be the ordering is wrong. It could just be 1, 2, 3. I think it's 1, 3, 2. Let's try 1, 2, 3. Try 3, 1, 2. All right, let's see. This is only drawing one of the triangles to the screen. I know for sure the non-index buffers are loaded up with the right data. Is there some type of issue with the index buffer generation code? Alright, yeah, let's try to not update the data. I doubt that's it. Maybe instead of unsigned int, it should just be GL int. I think the issue is with unsigned int. I removed the updating and the second triangle still doesn't draw. Let's try with shorts. So we want int to be short. And int little to be short little. Whoops. Let's not get rid of float. The problem is, I think we need integers. Oh, he's fixed the name. But it would be good to see, no, this isn't the issue. So we go 0, 1, 2. Oh, you know what? I think it's 0, 1, 2, 3, 4, 5. Yeah. I was thinking wrong. That's the issue. So we go back to integers. The shorts wasn't the right idea. Whatever, we'll just go back to where we were and change the types. Let's keep the good name though. Buffer. So ChatGPT did know the answer. It just wanted to hide it from me. These can then be int. And we can put our wobble back in there. No, we lost the triangle man. And now we know why. 0, 1, 2, 3, 4, 5. Hey! We got an indexed thing. I think it's time to build a real shader. I'm gonna make one more cup of coffee. I gotta think of the attack plan. So what we need is the matrix class. And I'm a bit more trusting of the code that I have, since it doesn't look like, let's ask ChatGPT, is there a built-in Kotlin matrix class Android.graphics.matrix? Can you make an example of an extension for Android graphics matrix that includes ortho? No, I'd like a trickier thing. Let's see. Can you convert this whole class to Kotlin? You better not ask for a tip. No, finish it. Finish it. Finish it. I'll pay you later, I swear. So obviously the scene kit matrix doesn't exist. So we don't need all this crap yet. We don't need that one. And we don't need invert. I'm a little skeptical if it did it right. Well, this is next level. Just gotta trust it. The real question is, does it run? So I think it needs to be a bufferable thing. So this bufferable should be float bufferable, perhaps? Yeah. This one is float bufferable. And then we also want an index bufferable. Let's make sure it still compiles. Yeah, and then the matrix, and we don't want it to be called 4x4, just matrix, is float bufferable. Oh, how do we conform to that thing? We've got to look up how Kotlin works again. So the way Kotlin works, yeah, it looks the same. Colon, blah. Then we've got to override these. Okay, but there's something in the blah that's missing. No, just somewhere where we set float bufferable, it puked on us. Oh, maybe it goes after that. Float bufferable. And then the size of this one is 16. And we put all these into there. Oh, whoops, I'm doing it wrong. Let's see. Oops. Oops. So instead of var space, what we want is buffered output. Buffer.put. And then instead of equals 1.0, we want close parentheses. And then instead of equals 0.0, we want close parentheses. I don't know that's the right order. Alright, so make wasn't the mistake. We can keep make. Alright, let's commit to our repository and make a backup right here. So this backup is at the moment when indexed sprite shader, and then we'll just go there. Indexed sprite shader. Fine. Now we make the same thing. Actually, I think the exact literal thing we used to have. Maybe not renaming anything. Maybe just exactly the same as it was. Maybe they don't even need to be renamed or like new files, just use these files. Maybe renaming coords to coordinates. I don't really like coords. Yeah, let's do that. So everything that says coords, how do I replace with coord and nets? Coordinates. Coords becomes coordinates. This isn't test. These are real shaders. This is gonna work with our indexed plan and everything. So first we want to get it up and running as a test. So it's actually going to be quite a chore to do this skip bit. And in fact, mini chores should come up throughout working. Pipeline. So I want to rename all these from Sprite to like some kind of demo thing. And make sure it still works. Demo. Demo. And demo. And we really don't want to keep slamming the shader with a string on every render call. Like those should be loaded up once in the beginning. All right, I forgot my coffee. I'm gonna go get the coffee. How do we clean project? How do we rebuild? Rebuild project. Just to make sure it's greased up. Yeah, it's greased. So these are our first real shaders. And they happen to be exactly the same as they were. But here's the sticky bit. We got to combine these things together in some smart way. Like which thing? These handles it looks like the nomenclature is handle. So there's some of the handles. Let's copy those over. So somewhere in here, we want this same shkabiznit along with these other variables. Yes, the modulate color. So that opens up another can of worms too, the modulate color. So it's wildly different than metal because we cannot clump up this stuff. It's just flat. So I think doing some duplicated work here Alright. These strings come from the program. So we need an interface. Maybe we don't need an interface. We just need a bunch of separate little programs. I'm literally gonna call this shader program sprite 2D. I think that's a final name. Nah, but we need something like shader program. All right, so we're going to have shader program and then shader program sprite 2D that is a shader program. This, I mean, I believe we had a similar thing in this old code. Yeah. So we need something similar again. But it's not going to be quite exactly like this. Yeah. But the point is, we need a vertex shader and a fragment shader and a program ID on all of them. So really, shader program, yeah, we'll keep it a class. Let's ask ChatGPT to do this for us. So we need a var vertex shader, fragment shader. I don't know how, can you set up the Kotlin inheritance structure for this? So it looks like an open class. Yeah, I'll just put what they got. The only thing is, I want -1 because, oh no, 0 isn't valid. tricky because with like a texture or something, those are valid. And it looks like to do the inheritance, it goes like that with bleh. All right, so the real call we need is use program as such. So I want graphics to have this for us, and we'll just make a function called program use, which takes a shader program. Whoops. And maybe they can even be optional to avoid needing to worry about that. These things rarely make or break the speed, so it's good to be safer. So we can say if it dot program is not equal to 0. And we could just put all the different possible things that we could have on a program on a shader program. Oh, my brightness went down. Oh, I got super low brightness. Not on this screen, on the other screen. But yeah, let's slay away. So we're learning Kotlin, we're learning Android, growing in skill. Trying to see just how far can we get with Android in our first day. So I want to go back to ChatGPT and say, yeah, we'll go back to ChatGPT. Say, I need it to be where vertex shader int and fragment shader int are constructor arguments to both classes. You know, let's do it like that. Alright, then in the pipeline, alright, so there's a little error here. These are 2D. So this should be named, I guess the name, there is no name in the file. Let's find these in Finder. So I think we can just call it sprite 2D fragment, and we don't need the word shader. And this one can be sprite 2D vertex. Yeah. So we're doing a lot of crap at once. So there's a lot of entropy here. This is crazy math right now. So the real program, or let's name them functions. So I'm gonna say val function sprite 2D vertex. This is how I want them to really be named. And sprite 2D fragment. And then program sprite 2D. So these are relatively kaboom. Add this boy here, this boy there, boom. And this, boom. And then this guy, kaboom. Then we grow this thing with these grow, and we're done. I think it would be nice to have some input or some All right, so there's this load program function. So this actually can go on the shader program and even be private. And we can have our init, and we can shader program load it. I think we should have a name too. Yeah, let's have a name. So every single one is gonna get a name. Because when we're debugging, that comes up as an issue. And we're not really going to be using the name over and over again. And I think it'd be good to have a good printout here. And if one of them is like -1 or some weird number, we'll see it relatively quickly. And here's the weird thing I want to do. So I want to say like if vertex shader greater than 0, these got to be in the quotes, and fragment shader greater than 0. Otherwise, we want to point out the problem. And in this case, we can just set the program to 0. But in this case, we can set the program to... Yeah, I think we don't need that function to be a function. We can just plop it right there. Might be fine to have it as a function. It's kind of a unit of code. It's kind of a lot at once. All right, can we build now or what? Oh, this is sadder, not shader. Sad program is sad. All right, so we can see that this shader program was created. That's cool. You know, I think the way the printout should work is a little different. Like, because we can print the program index too, in case that comes up funny for some reason. Otherwise, we can print failed. So we'll just put success or failed. Create shader program. And then we'll just put that right there like that. Alright, so we need, in addition to Shizzard or Crumpster, some new thing again. Let's call this Zippo Hippo. Let's just call it Zippo. Oh, you know, we didn't really finish what we wanted to finish with Crumpster. Yeah. You know what? We're not done with Crumpster. With Crumpster, we're not using one array. We're using two arrays. Yeah. All right, we got to do a little more work here. Might be good to test the shader too, or the shader program. Nah, I'm not too worried about that. Yeah, let's do it. Yeah, let's do that first. Let's first create the demo shader program, because we're running into too many variables, if I'm being honest. Yeah. So we'll make another shader program sprite demo. We'll just make a val shader program sprite demo, which is a shader program sprite demo. And we can move those weird attribute and uniform things into more compressed, or more compressed format. We'll minimize which thing might be the issue. But I honestly don't really expect to have much problem here. So we can just do graphics. What is it? Program use. And then library or pipeline, what is it called? Pipeline dot Shader program sprite demo. We kind of just, whoop. What does it say, toolbar? Dang, dude, I got lost. Yeah, these to here, to this guy. And we literally can just have, why is it attrib? Let's make it just attribute. And have it say attribute name. So again, if program is not equal to 0, and OpenGL is pretty safe anyway, but I like to do it this way. If a program is not equal to 0, then we can program as such, and the name is the attribute name. And then we just need uniform location to both attribute and uniform. And for that one, we can use the whole word, get uniform location, uniform name, uniform location, uniform name. Yeah, I think it's best if they all have everything. Attribute, location, position, -1. Texture coordinates, and then uniform location. We'll just name it like it's named. So in Crumpster, are we using color? I think we're not using color. So it's a little interesting. We might need like a offset or something. Well, let's do it in stages. So we're flying off the handle right now. This is getting to be absolutely ridiculous. And we do need the one uniform for texture. That'll just be uniform location texture. Now what is it, like super dot init? Or we don't need super dot init. I don't know why I can't see these functions. Oh, they're private functions. All right. We're still talking about the demo. So the exact strings for the exact names are those things. In this one, it is named texture coords. And this one is a uniform. This is like a little bit insane. So we can shrink those. Why does it all turn gray? Maybe that can't be used like that. Oh, I think the let didn't have a dot. Is that the issue? Yeah. So this is a program. But the good news is with each of these, we're increasing in our stature. What is this x equals 0? I don't know what that one is. Well, something should be wrong now. Which file is this? I can't tell what file. This file could not be GL20S. So we have two of same. I think we can just put the axe in Shazard. Let's make a backup in case things get dangerous. All right. So let's kill Shazard. Boom. Now anything that talks about Shazard, we gotta kill too. Okay, it looks like everything worked without a hitch. And we got that backup already. We don't gotta be too safe here. So the weird thing. Well, let's pack these vertices. That's like the other remaining big hump. And these can go in a file. We can call this primitives. And here we will make a is this? Defined at. Float bufferable. I want to do something similar to these. I'm not getting too crazy, but I just want something called position 2D conforming that has an X. Yeah, let's ask ChatGPT how to make it. How in Kotlin can I require this interface to have X and Y both as float, both as get and set? Oh, it's not letting me paste. Ooh. New chat. Alright. Let's do Gemini. Yeah, we said we were gonna pay them and we didn't. Let's remember that. That seems like almost wrong. Yeah, why? Bard doesn't know its own language. Jeez, man. See, this is why I like ChatGPT. Ooh, it's cutting me off. So Google, well, whatever. We don't need that definition right now. That isn't the real issue. So the issue is to make this thing called Vertex Sprite 2D. Which has XY UV. As a packed buffer. So this is like a real object that we could really use in our program. So let's make crump vertiz is an array of it's the same thing. It's these combined. Yeah, better to copy paste. Safer. Looks like there's an issue with it. Oh, I called them crump instead of this guy. All right, let's just get rid of the other ones. It's too complex. So we don't even want a position buffer. We just want a vertex buffer. And this is more like a final name. So a vertex buffer is a buffer of these packed mother truckers. Boom. Oh. What's the issue? Not enough information. What is Crump's vertices? It's Crump's vertice. Did I name it wrong? I can't tell which errors are real or not. Okay, so we just don't need these two things anymore. Those are gone. So I think we're gonna have to like offset this. So out of the box it should break. So okay, we're in the ballpark. Something is actually showing up on screen, which is shocking. So I think all the strides are bigger strides for. But yeah, so for this one, we need to offset this buffer. Maybe the IDX is different. Oh, how I wish I had ChatGPT right now. Yeah. Are you alive? No, it's cutting me off, man. Cold. Ice cold. So like my thought is like, is there like offset? I think one of these has to have an offset too. So the one with offset doesn't have the buffer itself. Yeah, I see. The what the hell is all this blue stuff? All right. I think it's just this simple. It's literally it's first enabling and then offsetting like that. What is enable called? It's funny because when you search for something, you don't navigate to what you searched for. GL enable vertex attrib array. GL enable, there it is. And then it is attrib pointer with our offset. I think just instead of vertex buffer, we plop in the offset. Is that it? It should run with the same problem now. Ooh, no, nothing. Let's read all the variables. Attrib pointer. And I can't read it. So exactly what we have in the other one is exactly this. So this would be the slot. Size of 2. Floats. False. I don't think the stride was wrong. Yeah, they're literally all same. So maybe it is the same thing for the other guy too. But where do we bind the buffer? Oh, so this is the one. We need GL bind buffer. We don't have a buffer for that. Yeah, see this, I knew this was gonna get nasty. Man, why can't it show you the variables that are needed there? Harsh. So it must be we need to generate the buffer, like gl gen buffers. Yeah, we need this stuff. I thought we had a buffer. So it seems like we need to bind that buffer. So we need to generate the buffer. So it's a little bit of a tricky business. Yeah, so I think it's just that simple. Fun buffer generate length returning an int. I think we should call it buffer array. So we got to do the same trick we did to generate the texture, which is to make that little array. This texture handle. Yeah. We'll do the same thing called buffer handle. One buffer handle. Man, I need the chat GPT, dude. convert these to Kotlin, please. You know, I think there was a mistake in this old code. Oh, dude, they didn't convert it all. I think that answered the harder question, though. No. Let's just go back to the old way. Gen buffers. We need an int buffer. What does the gen textures use? Nope, it disappeared. Gen textures. That also uses an int buffer. So it seems like maybe it's the needing the offset makes the difference for some reason. Yeah, that just worked. That one does work. And we're going at 1. Yeah, there's a lot more to that one little thing. So I think it's gless, not GL, but gless. Yeah. The bind index here is buffer handle 0. So I don't think we need this part. So there's some discrepancies in the old code which didn't matter, but it kind of does matter. It's all got to be done right. In Kotlin, how can I use something similar to void star to take any type? What about an array of any? Yeah, I have a sick feeling about that. So by default, we want -1 here too, because we're checking for -1 there. And this is buffer array right. The buffer is an integer. And the data is whatever if not -1. So here we just return buffer handle 0. Which is like a C wrapper, a crapper. Whoop. Yeah, that might be the same thing where we need like a wrapper for this. Because here we're looking for the length of it or the size of the buffer, yeah. Can we build yet? So we need buffer index as an int. And buffer content as like a buffer. So we did make the vertex buffer so ridiculously we could use like a size function too, like float buffer size, and all we really need here is that total size. Or we could just return this. And this returns an int. I'm a little lost right there. Oh, I think it's the where t. There's the return type. And then up here, we can just say total size equals float buffer size of that array. And we don't need this. And we can say let FB size equals it's not let, it's val FB size equals graphics dot float buffer size. These vertices, nil coalescing Elvis 0. Alright, then buffer index equals graphics dot buffer array generate fib size nil coalescing Elvis 0, and then buffer content, or we just want to do then graphics dot buffer array right. Oh, can't read that. The buffer index it's not going to tell what the variable is. Then the size, then the buffer. The size is FB size. Yeah, we're going way off the deep end here, man. So we might not need the buffer content right there. I don't know what that is. So there we go. We just put our junk in the buffer there. Kind of hard to follow. So then we can just bind it, right? GL bind buffer. Buffer index. No, I don't understand. Where do we use that in the other one? I would just say the type. So nothing's gonna work. The question is why? So there's the billion-dollar question. Is there any error? Oop. Let's read these errors and see what they say. Out of bounds vertex attributes. Allocated buffer size 24. Wanted end 88. So it could be like the FB size here. When we talk about that size, we really mean bigger size. And we don't have much longer. So maybe that is FB size times float dot size bytes. Can we even print the FB size? Oh, some shit just happened. Wow. I'm shocked. I'm actually in severe shock. Because something wrong is still I don't know if Logcat, who are you? Who are you, Logcat? Look at that. It's the friggin' thing. So it should be like the texture coordinate is offset by 2. Or it might be 2 times the size of float. But this should be an easy guess at this point. Yeah, maybe it's this float fib size times 2. Oh shit! That's crazy. It's crazy that it's too much stuff just for that. I think this is why a lot of people get discouraged from graphics because of that. What we gotta do is like consolidate whatever is going on here. So like obviously all this is like one unit of work. I don't know, man. So this is a good time to commit. The thing is, it's not moving around anymore. And I think the reason we want to figure that out before we commit. So like literally all these things have to keep rewriting. So we're rewriting the float buffer, but the we also need to do that guy there too. Maybe. So like copying from one buffer into an OpenGL buffer. All right, that's it. So that's like that really is packed indexed vertices. And unfortunately that took a little bit longer than I wanted it to. So based on this, I don't think we're gonna get all the way to the Earth on our first day, but I think it's gonna be a good first day. It's funny because I forgot about a lot of those steps, and I remembered some of it by experiencing it over again. We don't have much longer. I'll be back. Now, I wonder, no, I don't want to interrupt the movie recording. Let's think about it for a minute. How can we organize this buffer into something more manageable? So we made this float bufferable protocol, or interface rather. So I think like the object to create would be, I would just call it a packed buffer. Or maybe a graphics buffer. Yeah, I'll just call it a graphics buffer. And we got to think about what all stuff is needed with that. So little wild. So how can we want like 2 ways to initialize it? Let's ask ChatGPT. So I have a simple buffer class. I need 2 ways to initialize it. One way is with an array of bufferable. One way is with an integer named size. This is Kotlin. Okay, so there's 2 constructors like that, I see. So really, this should be an graphics array buffer. And we can have another one that is a graphics index buffer. Yeah. So one way is with the float bufferable. I don't think we need to store that data. The job of this buffer isn't to store a copy of the data. It's to be an interface to the graphics representation of it. But there's 2. It's a little weird. There's 2 buffers. So I think we want that one. We want both of these things. We should make a backup, because this is very delicate, if I'm honest. Sometimes going a little bit astray can cause a real setback. No, I don't know why everything turns gray. So we're gonna have that buffer and then this buffer index. So where's all the places we're using buffer array generate? And graphics array buffer needs a reference to graphics as well. Or what we call the graphics library. So we also need that in both cases. Graphics library. Whoops. We can do the same weak reference thing here. Can you do an else with that? Well, we can, yeah, let's leave it optional. I think that's, let's ask, can we do an else? Can we do an else if graphics is null? Okay, so the syntax is a little different. So I'm a little stumped. You know, maybe this init is confusing it. Oh, we can ask ChatGPT. How can I initialize vertex buffer? This has some error. Okay, so just that it's not initialized in all paths, perhaps. And we need a size too. And really, these should be vals. Could be a var for the index in case we need to regenerate it. So these ones is kind of redundant for just size. We can say, how can we do similar to Swift where we say self.size equals size? This dot size. So really, in this whole path, we don't need like one for the graphics having the graphics. No, we do. But in both cases, we do this. This dot size equals size. But in this case, buffer index is graphics dot buffer array generate of our size. So in the Crumpster, vertex buffer is done this way. And then the buffer index is it dot. So we need two. So buffer array generate and one just with no, this is fine. We already have our object. So we can get the float buffer size. So we can say size equals it dot float buffer size data times float dot size bytes, or I'm sorry, data, or I don't know, outside of there, stay out of there. So we generate of size, and then we do it dot buffer array right at buffer index vertex buffer. I'm sorry, the size again, size and the buffer. Well, we got all the code paths filled out now. Oh, maybe it's the graphics like this. No. We gotta ask ChatGPT, what is the issue here? It seems like things are not initialized correctly. Okay, so we would have to initialize that graphics reference. It doesn't automatically see that. Is that it? It says property must be initialized or be abstract. You need to ensure that all non-nullable properties are initialized. So I'm a little confused about the .let. So that counts only as just one path. That's not like an if, but it could not happen. That's confusing. No, that's not the right answer. I'm quite confused. So is there not an else case for the code in the block is not guaranteed to execute, correct? The code inside the let block will only be executed if graphics is not null. Yeah, that's what I just did, the run. So we're initializing size, vertex buffer, and buffer index. And we're initializing vertex buffer, buffer index, and size. Those are the three. And graphics ref, right? So this case, how does it be initialized twice there? I don't understand. But that still doesn't fix it. And these all need to be torn down and set back up too if the app goes in the background. No, I'm like bamboozled about this constructor flow. Because I see size and vertex buffer and buffer index 1, 2, 3 and 1, 2, 3 both. So we just comment out the other constructor. So we'll pretend there's just size. The only variable that's there is size. What's the issue? The alternate code path is that one there. If I move this out of the conditionals, that's a valid execution. Yeah, no, that's just wrong. Look, this is set twice. All right, maybe like maybe everything is like optional. Like float buffer is optional. And we just by default say size equals 0, vertex buffer equals null, and like buffer index equals -1. But in this case here, then we have to do the vertex buffer dot let. Was that cool then? Well, that at least works. But logically, I think the other answer was correct. So there's a bug in Kotlin as far as I'm concerned. So let's see if we can add the second constructor again. You know, we don't need that right now. That's overboard. Nah, I want it though. That's like part of the learning. So that there is the learning there. Alright, so we're still cool for now. So can we really use this graphics array buffer on Crumpster? So we'll make a private, or just a val Gabo as a graphics array buffer. Then when we fire this Mamma up, let's get dangerous. Let's just get dangerous. Gabo equals graphics array buffer. Shit, man, we can't see the parameters. Graphics, the data. And we can't see the parameters. So the parameters, no, there is no more parameters. Yeah, so that's good and simple there. Any issue there? Crumps verts is what? That's an array. What's the type of that? Can we print a description of it? What I need to see is the type of that variable. Well, not that important to see the type of that variable. Is Gabo still has a bug? What's this bug? What's it say? An array of float bufferable. So Crumps verts is an array of vertex sprite 2D. And vertex sprite 2D is float bufferable. Yes, yes, it is. Shit, dog. As near as I can tell, it is that. Oh, maybe like it's more like a generic, not like anything. So like this T business, like they're all one sort. Yeah. I don't know if it's gonna work. I'm just guessing, man. know shit about Kotlin. It goes there. And there? I don't know where it goes. Whoa, man. Let's see if we can we make this class generic? It looks like my syntax is wrong. Okay, so they do it like that way. That way there. So then these are not those, these are T's. That's the way it should be for this, because they're not mixed type. That's something, my own mistake. Okay, that fixed it, wow. That one was completely logical. I'm not gonna lie, that was 100% logical. It could be that is somehow related to the, oh. Okay, so we gotta specify the type here. That makes sense, that's fine. That isn't something that doesn't make sense. We just tell it the type. Boom, there's the type. It's that type. Now why did index buffer go puke? Oh, we still need that one. All right, so there's Gabo. So interestingly, we've got to be able to rewrite the data there. It seems redundant. We put it in the buffer and then we put it in the OpenGL buffer. It seems redundant, but it also seems right. So just as we have, we can copy this sort of syntax and just call it right. I'll just call it right. It doesn't return anything. We don't need to re-specify T's type. Maybe this is the answer. We're just overwriting the data. We should already have our size. So we really want these to be optional in graphics. No. I think we can say, whoops. Float buffer arrow. Any problem there? So for int buffer, we can do the same. So we can say int buffer.let int buffer arrow sauce. And those boys there. So the buffer here, optional to do buffer dot let like so. Then we probably just need another one to bind a buffer, like buffer array bind. That one should be good and simple, like literally just this bind call if we're not -1. So this too should be optional. So I again have a feeling something is wrong here. And graphics bind buffer should just be able to bind an array buffer object like so. So let's look at this. Yeah, so we just need that. And I kind of hinted to it already, this buffer array. Oh no, well I hinted to something else. Buffer array bind. Buffer array bind. Taking one of these, optional. We have two things called buffer array bind. So these are like two different functions, different overloaded, overrided. What's the issue then? One type argument expected for class. Oh. So we need like the generic typing for this guy, which the same constraint. Let's see if it's gonna explode it with that complaint. Where'd it go? Yeah, so that's again logical. So where we put it before there like that. And then these same complaints there. And then this guy is of a T. that correct? Whoa, why did it minimize? So there's Kotlin, man. I mean, it's cool. It feels like it's unfinished somehow. What are all these errors? Because that's not question mark. So there's not this crumps vertex. Yeah. So we could just reuse the graphics function there. Oh, we are doing that. Isn't vertex buffer a float buffer? It is. What's the issue with that? So I think the conformity is blowing up in our face right now. So this can instead be graphics buffer array bind. What we name it? Gabo. Alright, well, we don't need this function yet. We're gonna need it in like a minute. It'd be good to get a confirmation that something works first, and it doesn't. Maybe these are this dot graphics. I don't really know. So we don't need this for now. Let's minimize the potential issue space. We might not need like the weak reference. We can just have this be a var. And we just said this dot graphics equals graphics. Probably the same error. I don't know. Hey, look, it's rendered. So I'm a little bamboozled about that one. I mean, these are harsh things to have come up while you're trying to configure this, but yeah, this is, I guess I can do this. Oh, what's wrong now? So let's do the same here with the underscore graphics. Sweet. The only thing is the little corner isn't moving, so we do have to get that right function to work. So this T, you know, maybe now it uses the T of the class. Yeah, I think that was it. We gave it its own T. Got it. Got it. All right, let's try the rewrite thing from Crumpster. So we got our wobbly variable. So then we take gabo dot write crumpsverts. That's it. There it goes, wobbling again. The other thing to consider now while we're finagling things is the index buffer. So I think we just want our own. Well, let's look at what it looks like. This one should be easier, much easier. There's not any type confusion. But this is a good spot to commit. So that was what I said I hoped happened, and that happened. So I'm gonna navigate there and do git add all buffers. So this will be like the moment of bufferage. I'll just call this custom float buffer object lol. Well, now we can rename it back to zip. I don't think we're gonna need it. So let's not think, let's just build. So there's graphics array buffer. What's the other one? Now we gotta look at it. Shoot. Holy smokes, man. So we don't like call this something. So this one's a little different. So maybe we don't need any wrapper. Yeah, we might have gone far enough here. So we're gonna wanna like put this into the graphics and stuff, like wrap these and somehow make it so all this stride and crap is, to be honest, that isn't the hard part to figure out. I think there's not much issue going on here. So what about making a buffer? I'm trying to think of it. What did I have in the other project? Like, I don't want to keep referring back to the other project, but I think there was just one buffer called buffer. Doesn't matter. The old project is actually irrelevant for this stuff. This is all done much differently now. Yeah, I mean, I don't think we need too much wrapping paper. I think the problem before was having too much wrapping paper, which isn't really that meaningful. So this is like a good regular old Kotlin object int buffer. There's not like a second buffer. There's just that buffer there. It's a little bit crazy. What are these? Are those used anymore? So there's a question I have. So like, if we didn't write twice, where'd it go? If we didn't write this twice, would it matter? And am I doing this float buffer right somewhere else? All right, so that's absolutely necessary. I'm pretty sure the second one is absolutely necessary too. Yeah, it's copying all the data twice. I can't think of a smarter way to do that. All right, we just don't need this. We don't need this second init. Okay, then I suppose we'll make this Zippo thing. So Zippo is next. But we can reuse the stuff from Crumpster. So actually this is going to be pretty similar to Crumpster, but this is more of a matrix test. So let's just jump into it. Here we are. We're not doing Crumpster, we're doing Zippo. Now, let's make a new one. Because I want them to have a little bit of a different positions so we can see them both at once and make sure that we're all cool and stuff. That's easy enough, it only takes a second. So I'm gonna call this Zippo verts. And they're just all gonna be plussed instead. So plus, 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 plus. And then these will be minus, 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 minus. Let's just build this guy. So just as we have McCrumpster, we gotta have Mazippo. So there's that guy and the mother trucker getting involved this and that way because of this and that. So let's build the thing, same arguments, but we'll use the other bitmap 2, just to see some change. Be good just to get it drawing without much change happening. So I mean, we're really putting this together sloppy, but it can be cleaned up much more easily than built up the first time. So not too worried there. But here it's gonna be the Zippo verts. And let's manipulate a different vert. And we'll just have it be a different number, like 0.4 or something, I don't know. And we're not doing crump verts, we're doing Zippo verts. Let's just see if it works. Yeah. Yeah, I think that wobbly vertice can be a bigger number, like 0.7 or something. Maybe instead of, yeah, that's fine, whatever. Yeah, so that's a little interesting. It's fine. This is behaving correctly. We're not doing a triangle strip, we're doing a triangle list. So the issue isn't this issue. It's obviously is a different issue. So can we delete the things called shit? I don't like that word in my program. Let's delete the shit. So no shit, nothing. And then we'll delete this shit. We'll let the compiler tell us where we're missing stuff. Yeah. So the whole thing there. So literally we can get rid of triangle. Its lifespan is over. That was it. Just quick life. So it wasn't drawing anyway. And now it's dead, just like it's supposed to be. Cool. then it's gonna turn hectic right here. I think the first step should be with no matrix and getting the color to work, because otherwise it'll be hard to tell what's going wrong. So there's the modulate color, and we can keep that name. But this thing here, I just want to go back to what I had before. Where's the test one? Oh no, 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 no. There it is. All right. And we're gonna have to do less and less with each of these that we add. The hardest parts are pretty much done. The thing that's gonna be hard still is the frame buffer rendering, but I don't think we're getting to that in our first day. It's the amount of speech has really slowed it down. What am I looking for, man? I don't, yeah, this. All right. So how exactly did I name them? I should see how I named them in my Metal project, because I've really thought a lot about these names. I think the names is literally like projection matrix. Yeah, they're these names specifically. And in here specifically, it's named that way too, so that's good. So here it can be named that way too. So uniform location, projection matrix, and uniform location, model view matrix. Whoa, what the heck happened there? And then what is modulate color? Is that a uniform or something different? This I'm pretty comfortable with right now. There's not really much difficulty going on right at this moment. So I'm pretty familiar with this territory of just adding integer variables. Uniform location, modulate color, boom. So it's gonna be pretty easy because we're gonna have like all this stuff. And I think like graphics will just be able to like handle these -1 cases, and we won't have to be super careful like about all these little crashes. Sometimes a crash is good. A crash can tell you what went wrong. Sometimes the hardest thing of all is figuring out what went wrong. So the little nuance here is the word texture coordinates. I think other than that, they're named the same. And then we just get three new 3 new guys. 2. Modulate color. It's getting a bit bigger. But we're really eliminating potential sources of failure through observation. So somewhere we didn't copy the one called modulate color, which is that exact name. I really am a big believer in copy paste for stuff like this, where it just literally has to match exactly what it says in the other file. So why are these all riding the complain train? Is like a string not closed or something? I'm a little bit lost. No, I'm still a little bit lost. How can they all be in error? What if we clean? Will it tell us more what the error is? It says line 7. But line 7 is empty. Line 11. Well, you know, I'm just gonna copy this file again and see if something is named wrong or like something. Okay, so I don't know what was wrong. So if I paste that other code back there, does it go wrong again? No. So there must have been something wrong. Oh, maybe it was missing name or something. I'm not that concerned about figuring out exactly what it was. There's not a... I mean, it would be good to learn a little bit deeper the language, but zooming in on that isn't like I mean, we gotta get this out the door too. I'm not sure to who or what it is, but we gotta get this out the door, man. I mean, this gotta be done like today, whatever this thing is. Learning has got to get done like ASAP. So let's make some matrices. Well, yeah, we'll I'm confused. We need a class called color now. A float bufferable color. So color should be float bufferable. Man, so it needs the parentheses? How is it that I can't declare? Is it because it already exists? Huh? Or maybe it has to be a data class? I don't even know, man. Let's just copy matrix and make color into, or matrix into color. No, that's too much. That's like overboard. Let's be calm. So we need red, green, blue, alpha. Then we need like, let's give it 2 constructors, 1 empty constructor, and 1 that takes all the arguments. This is good Kotlin practice because this, like, I can at least think more about the language right here. Oh, it's not self, it's this dot red equals red, green, blue, alpha. And we don't have long. It's that thumpity thump thump. So maybe we don't need to specify those constructors. Yeah. So in this one, red, they're all like 1. F. And then again, we just do RGBA, writing to the buffer. This just makes it good to copy over these objects into the graphics buffers. The other thing, like, that we could have in our graphics library is to just generate a buffer from one object. Yeah, that's what we need. So float buffer generate with just an object or just an item, which is not an array but just a T. And how does float buffer size work? Just the object dot size, that's it. I don't think we really need that much more other stuff there. So float buffer from the one object, and then the float buffer right, we need one for just an object, or an item as we've been calling it, for just one item of type T. So there should be a little space right there. So we can just say item dot write to buffer float buffer. and that would be it. We write one item to the float buffer. I like these generic type things. It makes life a lot easier. So like we're literally solving like 50 problems at once instead of just like we need it for float, and we need it for point, and we need it for point 3D, and we need it for color, and we need it for matrix, and blah, 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 blah. Nope, we just solved all those problems with generics. Now what? Nothing. So this just got tricky. We gotta really hone our focus for a moment. I think, yeah, we don't got long. Huh. All right, so oh, I got rid of the file I was looking for. What one did I want? Like Shrizzard or whatever. I think it's fine. So like yeah, shoot. Let's just make them one at a time. So we need the color and the matrix. Two matrices. Color matrix. We gotta assign those to all the right slots on the graphics card. So let's make these things. So I'm just gonna say val, or I'll do var. Var color is a color. Let's just give it like 0.4, 0.6, 1.0, 0.85. And then var projection matrix equals a matrix. And then var model view matrix is a matrix. What's wrong here? Oh, there just needs Fs. Yeah, that's getting to be annoying. That's good. I mean, there's, oh, it looks like the other constructor is already there. Okay, so no, so just by default, they have their default values. That's good. That's convenience you can count on. All right, don't need to fix that right now. We gotta get like meaningful digits plugged in here so that we can live in a real coordinate space instead of this hell that we've constructed for ourselves. This is hell. All right, so let's make a buffer. So var color buffer is a float buffer, right? And we may like eventually want these things to be more simplified so that they're not spreading all over the place like diarrhea. So we build all these things out. Then we says color buffer equals graphics dot float buffer generate for color. Nil coalescing Elvis Presley operator float buffer dot allocate 0. Is that it? Projection matrix buffer model view matrix buffer, and then we plug it in, and then we plug it in. So we gotta quit soon. So we're doing Zippo. So here, shader pro, this is where it's all gonna go haywire. Shader program. What? We don't even have the other one? Oh, it's just called program. Yeah, that's what we want it to be called. Shader program could be a good name too. Anyway. So just by doing that, we should have ruined like everything. So it just doesn't show up anymore. It's just gone. And we're just shit out of luck. So let's see what these errors say. It should be like that we're missing bindings in certain places. You know, it's tough because like these aren't the errors you would expect in this case. So I'm a bit confused. I am confused about these errors. Index is greater than the max attributes. So we just run it for a second, just for 2 seconds, and we just stop it right away. Can we read the top of that log? We can. It looks a lot like so the Sprite 2D has all like -1s for these numbers. So probably there's a clue there. A big important clue. Let's see if we can get to the bottom of it. Let's copy these names. Maybe the names have changed. Yeah, that's a lot. Not library pipeline. So I don't see these as the issue. Load shader vertex. And then load shader fragment. Those were correct. Shader program sprite 2D. It looks like we missed some of the printout, like it didn't print out the beginning where it says if it is success or fail, or the indexes of the thing. It's almost like it didn't call the parent init. But it looks the same as calling that function there like that. Oh, see, it should be println. So for some reason this doesn't get called, this init here. So not in neither. Oh no, in the other one, yes. So in demo sprite, that is called, ooh, let's ask ChatGPT. When I created one of these, the parent class constructor was not called. Why is that? Oh no, I can't paste. Jeez, dude. So it just doesn't like you going idle. It needs like constant attention. Gemini sucks, man. So we just need super dot init. Oh. No, I'm lost. Cause here it happened. It did happen. Oh. I don't know. So the same thing again should yield the same result. We have to kill logcat. Well, it's pretty clear. Like, I think the program just isn't created. Because otherwise we would see... Oh, wait. Maybe it's on... No, we did create the program. Alright, so there's... Yeah, it's the println that is confusing now. So this is how learning works. Because we can learn right now about println. So we just learned that important bit. So it did load those things, and it did have a program. But in this function, is the program 0? It isn't 0. Attrib location and uniform location. It could be a bug in the code. Like, oh, you know, I think it's this modulate color just floating around down there, not with a comment. You know, what a garbage shit, man, because that is hard to deduce when it doesn't tell you what happened. Why is it red? I'm not sure if I understand why it's red. Oh, I think it's red. No, I can't say I know why. Anyway. So we gotta look at maybe the other program to see how do we do GL uniform. Yeah, so there's like, it's actually called GL uniform matrix and blah 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 and 4F and blah blah blah. So like for color, yeah. Let's see what they got for options here. This is hard. Whoa, what was that, man? Oh, no, don't convert. Okay, so we could just use this. We don't need all those buffers. I just can't see what the, okay, location. So that's gonna be the shader, what's it called, the program dot, let's do the modulate color. And then just literally color dot red, color dot green, color dot blue, color, whoops, color dot alpha. That doesn't seem to have any effect. Is there a issue spitting out? How does that one work? So we have to first bind the uniform. Nah, but the uniforms is binded there. Are we on the right program? No, we're not on the right program. Okay, so the problem could be bigger than we think. Yeah. So I think that worked that time then. Let's try tweaking the color. Like, seems like it's always red. Alright, but I just turned the red all the way down. Let's turn the green all the way to 1. So we've done a little bit of unnecessary work here in creating those like color or the, yeah, so there's green. Let's just make sure blue works too. Let's make sure alpha works. I'm not sure what should be the effect, just less intense maybe. It's hard to tell if alpha had an effect or not. Let's do it with all the colors. Yeah, so the is our clear color, but if we go to 1.0 F, it should be black 100%, or, oh. So that's not all correct. It could be like something is wrong with the pixels. I think that's it. Can't really prove it 100%. I think that math is like just a little incorrect. So if we just put the color, I mean, it seems more like that's the right color, just out of the box color. Yeah. Yeah, I think we should stick with that one. Little deceptive because that 80 sprite. Yeah, let's look at the colors again. But I have a decent feeling about this right here. I think it should be the earth texture. That one's the easier one to see the colors of. Yeah. So I mean these aren't like the smartest moments. Oh, I'm kind of fading out here. Well, maybe where is it? It's on the renderer. Is that where I put it? Yeah, there's the bitmaps. So the test.ping can be the earth one. And then we'll switch that with the other one back. So those is not the right colors. So I think in the other program, we did something to fix the colors. Trying to think what file it might be in. I think something outlets. OS core outlets. Not app shell. Yeah. This is just reminding me. It's just a huge shame because I went through all this work and only like 4 people downloaded the app. This is it. Is that it? Load image to buffer. I don't see any color shift. Oh, there's a pixel shift. Oh, pixel shelf, not shift. Hmm. I think it's just OS load image. Maybe it's done in the JNI file. Load bitmap. I think Google or Stack Overflow is gonna have this answer though. So let me try that. Kotlin, OpenGL2, bitmap, pixels, wrong order, wrong color. Convert pixels to RGBA. No. Is that being used here? What's this one? Get bitmap pixels. I think this was it. There should be this like bit shift happening somewhere. See if ChatGPT can convert this. Convert this to Kotlin. See if those are the right colors. Yeah, so that's actually the math right there. Or, well, I'm convinced of that. So I don't like this type of variable name though. Like obviously these shouldn't be like camel cased like that. That's ridiculous. We can call it RGBA. I don't want to remember why that works or why they decided that they don't like their device to work like the regular stuff. But yeah, colors are important. So then, if we go back to Zippo, I don't want to keep twinkering around with this. I'd rather get the matrices up and running and then put a knife in this thing. Oh. So like if the alpha is very low, so the alpha is not having any effect. Is the other colors having an effect? Yeah, I see the blue had an effect there. So if the alpha is 0, does it have an effect? Why doesn't that have an effect? I think the reason is blending types. I'm not gonna get hung up on that one right now. So yeah, let's real quickly get hung up on it. So if we make it 0.5, then we just somewhere just tell it to blend the way we want it to be. Yeah, they're all not like, whoop. You gotta enable the blend. I think this is because we need enable blend. We'll try that real quick. Yeah, so that works with alpha then. Fine, I'm convinced. But this isn't the issue that we're really trying to solve. So let's just go back to full on alpha, like 100% alpha. So this is the advantage of getting older, is having these memories that you can tap into to get over some of these problems. Now, there's also disadvantages with getting older, including death. That's something to consider. So for the matrix, I just want now the projection matrix. So we should go haywire again. So I'm just gonna say projection matrix dot ortho. Dang, you know, how do we need the width of the device. Kotlin, get the width, the size of the device right away. Fine, let's buy that. Yeah. That is. Let's see if it still runs. Alright. How do we get that? Does this one get it from anywhere? That's Java code. Is that the one? What is context here? Well, I think width and height are important ones to get. Does it print those size? All right, we'll. So it's a little confusing. These are the numbers. All right, it's 1080 by 2154. We're not gonna worry too much about that. Let's get the matrices running and then we'll quit. So we're not gonna get the whole Earth showing up in this first day. So the wowee factor is just not gonna be there for day one. Maybe. I mean, maybe, nah, it's too much. It's getting too late. There's all day tomorrow to do the same thing. So let's get the matrix and we'll call it a day. So literally like just plugging in numbers. Oh, there it is. So we'll get both matrices though. I think it's gonna end up being more of a task than it may initially seem like. But we'll just plug in these numbers. For now. Just to get it working on that device. And then we're gonna have to bind the matrix. And by the time it's all greased up, we might not even get there. But that's at least the goal, is to get there where like one of these things is spinning. That might be 2 hours away, or like only 45 minutes, or like 4 hours. I don't know. But that's kind of more realistic. because honestly, I'm getting a little fuzzy in the head right now. I've been going a little long. All right, so this is it here. So we need .gl uniform matrix for FV. And we should just have the projection matrix buffer. Is that the right kind of buffer? It's a float buffer. What does this need? What's the Boolean? Let's look. I think that like is like some other thing. The count, maybe? It's the number of the matrices that we're binding right there. I think we just put 1. Yeah, now it says count. So it's int. So we see right here in the other program, it's like 2 ints. So the one int is a 1 and the other one is a 0. I don't know why. 1 0. Oh, for transpose. So there's a Boolean here, so I think it's false. Like, we don't need to have the system transpose that. I'm not sure why it's this projection matrix buffer. It might not need to be this. So they're gonna compile and not crash. It's not crashing. So it gets hairy here. So right now we're not using the matrix. And this is where we don't know what that ChatGPT code did. But we can multiply that vec4 by just projection matrix. And we should get some goofy result right now, like a little tiny dot or something. I can't tell if there's a little tiny dot there or not. But in any case, we need now real numbers, man. Like screen coordinates. So let's see if it really works. I have some feeling, well, yeah, we'll get a look at what it looks like. That's what we'll do. Where'd it go? It's gone? Shoot, dude. I believe it's gone. Well, we don't need these prints. No, it's there. Zippo. So like the numbers essentially need to be real numbers, like screen coordinates. So like, I'm just gonna pick numbers like 100.0f and 100.0f. Should make them higher numbers, like Whoa, what? I can't type with that box. 600.0F and like 200.0F. Then what is this one? This is like the right side. So we need like 1000.0F, and the Y could be like same thing, 200.0F. And then now we're back at 600.0F. But this Y is a higher number, like 1200.0F. And in fact, all the big Y's is going to be the same. That one, and that one, and then the little guy here is the little shrimp. There he is. And then one more shrimp. Shrimpy dimpy. And then the big well, this is the little one. And then this is the big one. Or no. Shoot, man. 0, 1, 2, 3, 4. So this is the big one. They're both the big one here. Big one, big one. Let's see if that might be right. Something shows up. No. Nothing shows up. It's a little bit concerning. That was what I kind of feared. Was that there's just going to be nothing shows up. That's the hardest one to solve. We should easily be able to pinpoint the issue. So if we go back here, or back to here, and we just simply comment out or remove projection matrix and run it. Well, now the numbers are all skewed, so it's harder to tell. Yeah. So we're in a bit of a conundrum. I think we want to keep 2 versions of this stuff floating around. Yeah, I remember these issues are just the terrible issues. We don't know if there's a problem with the buffer. We don't have really a good clue as to what the issue is. Like, we can't really inspect those buffers. Maybe we can, and we don't know how. But yeah, let's see if this goes back to like, yeah, there it is showing up. Now here's a silly question. So if we don't use, we just use the projection matrix as the standard identity matrix, does it show up any different? That'll give us a good clue as to whether or not this thing is leaping into the graphics card or if it's getting stuck in somewhere in transorbital space. So we could just comment that out. That'd be a good quick hint. All right. So it's a transorbital issue. So I just don't know the contents of this buffer. Maybe it isn't written in the right order. Let's look at the order of the other one. We should have that somewhere. I think we just do .m. Where's our matrix? There's just some function called like m. Isn't there? Oh no, this is the wrong project. So we just need like .m somewhere. .m, is that it? I don't see it anywhere. Well, this is getting hairy now. So there's that .m function. Or .m. So we need the CPP file. We go in this order. We got to go in that same order here and make sure that we go in that order. 0, 0, 0, 1, 0, 2, 0, 3, 1, 0, 1, 1. We are going in that order. We end at 3, 3, 3, 2, 3, 1. Yes. Fine. So look, can we see the contents of that buffer? Is the buffer the right size? There's a lot of questions to wonder about. So let's have ChatGPT go to bat for us. How can you print out all the contents of a float buffer in Kotlin where each in this format? So print index %d equals %f. Yeah, let's see what's in there. Oh look, there's this cache syntax. I don't know about that. See? Learning. So that looks like the identity matrix. Not gonna lie, that is the identity matrix. We have the right matrix there. Oh, I think we're binding to the wrong slot. Yeah, so the location here is projection matrix. Hey, all right, so there's the identity matrix again. Are we really doing it though? Let's make sure we're doing it. Yeah, we are doing it. Cool. That might have been the hardest step there. Just making sure that is lined up. Oh boy. Alright, so projection matrix like so. Now it should disappear or go to that top corner. Can't really see if it's up there or not. It might be behind the status bar. But anyway, so then if we switch back to these vertices that are more like real world vertices, we can get the thing to show up. That works. Cool. So these are like real world vertices. Then let's make our wobble pixel a bit different. We can go back to the first pixel or something, or we can stay where we are. So like this is the left, so 600. So let's just wobble it by a whole 100. And we should get our wobble back. I'm a little lost as to what's happening there. So if we don't change that pixel, like I picked some wrong number somewhere. So we're left top, right top, left bottom, left top. What, or we're going 0, 1, 2, 3, 4, 5. Okay, so the order doesn't matter. So we have 2 on the bottom. We need two on the top, or two on the high Y. I'm just guessing. Yeah, that worked. Good guess. Then what about that wobble pixel? Let's re-wobble it. Will that get the wobble working? Yes, there's our wobbler wobbling again. Okay, then we need the model view matrix. So for this one, we need like rotation Z. Let's look at the I don't know if it can just convert this function. Convert this Swift code to Kotlin. So maybe that's the more gentle way to use ChatGPT, is to just kind of be more gentle with it. Is there like a cos F? It's Kotlin, not Swift or C. All right, so we'll use just that function, rotation Z. And then, well, I'm less worried about this step, but we can still run into a time suck here if we get a bad dice roll, or just some bad, just garbage luck happens to us. So let's go deeper into this model view matrix. Where are we at? Zippo. There's the model view matrix and the buffer. We're already doing it. We're making the buffer. So we want like var spin equals like 0.0f. Then we want this same code just to increase the spin. Maybe at a little faster speed, 0.5, something like that. And then the model view matrix, we just are going to do rotation Z of this spin. And then we want to write that float buffer right our matrix to our matrix buffer. See how good that like reusable code is? That is like amazing. And then all we got to do is just stick it in there. That's it. And we should be golden gold. So let's do model view matrix. Well, okay, so there's going to be one other issue, which is that like we're going to be orbiting around a weird spot. If it worked, it did. Pretty clearly tell that it worked. That's, you don't know how cool that is. There's a lot of stuff has to be linked up to get that working like that, and that is no small ask. So let's give it a cleaner spin. Yeah, so like instead of all this, let's have like negative 512 and 512 and blah blah blah. Just to see if we get like a smooth, clean orbit. We can do another weird little thing too, which is to like translate the matrix. I think like We might be not on the right track with this matrix, because we need like a fast multiply. It don't really matter. To be honest, that's, unless there's like millions of particles, that's not gonna matter. We're not doing millions of particles in this demo, but if we're making like a game, we might want to be a little more, even using the AI matrix multiplication algorithm. So we should get stuck up here in the top left, which we're not stuck there. I'm a little bit confused. Clearly something is happening. I think like we might need to multiply the identity matrix by the rotation matrix. Anyway, that isn't fully the big issue that we. No, I mean, it looks like we are doing like the identity matrix there. Let's see what the Kotlin code looks like. Looks the same. I mean, I see the 1.0, blah blah blah, 3.0, blah blah blah. I don't know if we're triangulated in the right triangulation. Yeah, 0, 2, 0, 3, blah blah blah. That's a little unexpected. Is the ortho function correct? It's not the easiest thing to tell. There's a lot going on here. Let's go back to Zippo. What am I doing here? What am I trying to think of? So we're going in the right slot with the right buffer. Where is the buffer being generated? So right there. Oh, just once? Oh no, no, we're writing it all the time. On every draw, we're writing it. So if we just get rid of that line, it should be in the upper left. Okay, it is. It is in the upper left. Oh, bro. No, bro. No. It's the ordering. So it's gotta be that order, maybe. The order matters. This is important order to take, man. It's important. And we don't got long. Man, I'm a little fuzzy in the head. All right, so if we just go back to this spin thing, now it should be spinning around the top left. All right, perfect. Then we just want to center it, like in a video game, to get it centered to the center. And we just need to remember the size. Hold on. Do we have the translation function? Yes, we have translate and translation. No, we really need the multiply function. I'm just gonna ask, can you add an efficient matrix multiply function to this? Oh, not adding anything. That isn't the way. Whatever, you know, we just need it to actually, yeah, let's have it use this. Use this code, convert it to Kotlin. Let's say, don't put the whole class, just the multiply function. Yeah, I think that's, the only thing is this name P matrix left could just be matrix left. And like P matrix right should just be matrix right. I don't think we need that though, even if I'm fully honest. Let's put it in there. We'll have that in there. Well, we really need, no, we do need it because we need rotate. I don't know the order even. I just will guess both. I think the order is the opposite of the one you would think it is. So the one you would think it is would be to first rotate and then translate. So the opposite of that one where'd the function go? The opposite of that one is to first translate and then rotate. Oh. Let's see if we can get a context. Can you add a function called reset that resets the matrix to the identity matrix? Anyway, so we'll do not projection matrix, but model view matrix dot translation, not translate, to like the middle, dead middle of the screen. Does that translate to the dead middle? Oop. It's a 3D translate. It does go to the dead middle. Then we need to not rotation, but to rotate to. So there it is. Oh, we only care about radians here. So we can say rotation matrix equals a matrix. No, what? Don't we have efficient of this code? No, we're just doing multiply. Yeah, I don't think there is an efficient one. Maybe there is. Maybe to rotate in here. No, I mean it's all the same lazy thing. I don't think there is a more efficient way to do it. Whoop. All right, so rotation matrix. There's a more efficient way to do the access rotation. So we make this a rotation by those radians. All right, can you make a version of this which uses the matrix itself as matrix left and stores the result on the matrix itself? Whoa, what happened there? Restores the result on the matrix itself and doesn't have a return type. Yeah. That's the one we want. So then in this guy, we just say multiply by this rotation matrix. And this can be a val, I think. Are we doing it? That's it, man. So it looks like their math is correct. So I mean, all this crap, I would have made like 4 mistakes there. So I mean, it's a godsend to have that automatically done. So I mean, let's look objectively at what happened. The goal was to build this in Android and Kotlin. I'm quitting, by the way. Like, I just don't feel like it's healthy to keep going right now. But yeah, I mean, that's we're on the way, we're on the path. It's more than can be done in a sitting. But the good thing, the great thing, was learning all this Kotlin.